We'll wait for another 2 minutes. Let us start dot on time because some students might join dotted on time. तब तक कोई major doubt है? You have 2 minutes. Anything? Any major doubts? सर डाउट तो तब होगा जब पढ़ेंगे. कल संडे था, लाइफ में और भी काम थे, बीच में क्रिसमस भी था, सांता क्लॉज घर आए हुए थे. नो डाउट. यंग मैन मास्क कहाँ है आपका? सफोकेशन होती है. आपको पता नहीं कोविड होने पे कैसे सफोकेशन होती है ना. मुझसे पूछो, सांस रुक जाती है ना तो पता लगता है सफोकेशन क्या होती है. आई वुड सजेस्ट ऑल ऑफ यू टू वेयर, मतलब don't behave careless. I wouldn't say uneducated, I would say careless. I think I said in your class, the window to COVID is carelessness. Did I? No. अभी बोल रहा हूँ. ठीक है, डोर भी वही है, डोर विंडो सब कुछ वही है. ठीक है, और हम में से किसी की नाक इतनी सुंदर नहीं है कि दिखाने के लिए नाक के नीचे रखें. ठीक है, तो अपनी जान की रक्षा खुद करें. And this is high time. I don't know how many of you are from outside Delhi. You're not basically from Delhi and have come. Oh, that's exactly why you are behaving this way. You know, Delhi वालों को ना बहुत अच्छे लोग समझना होता है. Right? Yeah, come over, ma'am. We haven't started yet. We are still waiting. Okay. So, and you don't know how Delhi behaves. Last COVID second peak, almost every other house in Delhi was COVID positive. Okay, almost every other house. I should say more than that, maybe more than 50%. And in the next few days also, you will have most of the Delhiites again being either asymptomatic because probably they have been vaccinated. Okay, probably in January. We are going to see that peak. It is bound to come. So अपने आप को थोड़ा सही में, I'm serious, right? देखो बच के निकल गए तो निकल गए. I say COVID is like a lion on the street. You don't know whom it will pick. Whoever it picks, and when I say pick, it doesn't mean pick as in become COVID positive. When it picks, you're gone. Or you're next to gone. That's what I mean when I say pick. Right, so it's not your health or your physical fitness. I've seen pretty young people close to in my ICUs when I was there. I've seen very young people like you also. Probably आपसे थोड़ा मैं ऊपर नीचे होंगे. Not kids. I haven't seen kids, but at least pretty young people in very pathetic conditions. Right, oxygen cylinder लेके टॉयलेट जाना पड़ता था उनको. उसके बिना मतलब take out the mask and they would be like. So I'm telling you also, please be serious about this. Take it seriously. It's not a khansi zukham actually. People are saying it is khansi zukham. It's not khansi zukham. The symptoms are similar to khansi zukham. ठीक है, सिम्टम सिमिलर होना और खांसी जुकाम होना में अंतर है. आपका नाक अभी भी दिख रहा है. ठीक है, so I will again and again say this to you, right? Please do take care of yourself also. I can't because even I would love to take class with mask on, but I can't. तो आप लोग मुझे भी बचा रहे हो और खुद को भी बचा रहे हो. Anyways, coming back. So let us start from. और ऐसा मत सोचना कि सर सुबह सुबह ही आप स्टार्ट हो जाते हो यार, है ना. वीक का फर्स्ट डे है, मंडे मॉर्निंग आप कोविड. हम यहाँ आईएएस का तैयारी करने आए हैं आपको. यार आप कोविड के मिडिल में आईएएस का तैयारी है ना करने आए हो. राइट, आई थिंक एक ऐसा मूवी भी था कुछ ना, लव इन द टाइम्स ऑफ कॉलेरा और समथिंग, देखा है ना. सो वैसा पोजिशन में आप, आईएएस प्रिपरेशन इन द टाइम्स ऑफ कोविड. तो थोड़ा सीरियस कंडीशन है. ओके, तो मजे से रहो बट इतना मजे से भी नहीं. ओके, लेट अस कम बैक. सो लेट अस कम बैक फ्रॉम वेयर वी वर. ओके, लेट अस start, uh, you know, recalling what we have done in the last class and slightly seeing it in a organized manner. So I think we started with the Big Bang, right? Big Bang around 13.7 billion years before present. BYBP is billion years before present. We saw that after Big Bang what happened was that there was some explosion. The older sources say that it was a single point explosion, because of which they use the term primordial atom. Okay. Recent studies have shown that Big Bang was not a single point event, it was actually simultaneous expansion of universe. Okay, so it was throughout simultaneous explosion, something like that. Which one is more right? We will go, right now we'll go only as per your NCERT. Primordial atom, we talked of the primordial atom last time, I hope you remember. Did I? Acha nahi, koi baat nahi, it will come. So when you read, that's why, probably you have read your NCERTs, wo to padha hoga. So in that there is a term called as primordial atom. They say that before Big Bang there was a primordial atom which exploded and the Big Bang happened. Right. So this was Big Bang. We won't talk of the primordial atom before this, but there is something before it. I'll come to this, because first you have to understand the content of it, otherwise you will think of it as a hydrogen atom or a helium atom or a uranium atom. It was not like those atoms. It was not atom as in chemistry ka atom. Okay, it was atom because it was a point source. That's why they call it as an atom. Right? Actual name is something else. So after Big Bang, the first thing we saw were the laws of nature. And in laws of nature, we saw there were 4 fundamental forces. And those fundamental forces were, the first one was, we started with gravitation writing last time, but here I won't start with gravitation. I would start with, let me say, the strong nuclear force. The strong nuclear force gave us the atoms. The atoms formed because of this. Atoms formed. When did atoms started forming after Big Bang? Within first 3 minutes of Big Bang. Within first 3 minutes of Big Bang, atoms started forming in the universe. Okay, and that atom was the most basic atom that we have. What is the most basic atom? Hydrogen. And actually, if you see hydrogen, in hydrogen atom there is just one thing, which is the proton. In the nucleus there is just proton, and around it you have an electron. That's it. Okay, so basically when this thing started forming, it wasn't an atom as in atom, it was just the proton starting. But a single proton also you can call as the nucleus. So that's why we say the hydrogen started. Why? Because it was ionized. It was in a plasma state to begin with. I hope you remember, हमने कुछ plasma state type भी बात नहीं किया ना अभी आपका class में. Okay. So when we talked of this, कुछ है नहीं हिम्मत? So within the first 3 minutes of Big Bang, first atoms started forming, which were the hydrogen atom. If you feel like, you can write this, right? तो ये साथ साथ बनाते भी जाना आपको, right? Hydrogen atom started forming in the first 3 minutes of Big Bang. The state and all I'll talk, don't worry. ठीक है? Hydrogen atom, and I would expect you to draw this flow chart. ये सब बनाने का कोशिश करना है, ठीक है? So start from here. Big Bang, उसका ऊपर थोड़ा space छोड़ दीजिए. Then laws of nature, 4 fundamental forces. The first one, strong nuclear force giving us atoms. So atom formed within first 3 minutes. Okay. Now what was the state of this atom? The state of this atom was extremely hot, because in the beginning the universe was extremely hot. Okay. So these atoms were in a extremely hot state. Extremely hot state. Extremely hot state. Okay, and hence they were in a plasma state. Plasma state. Plasma state is a high energy state which is attained at an extremely hot temperature. Right? It is neither solid nor liquid nor gaseous. When you go beyond gaseous, objects turn into plasma state at an extremely हॉट टेम्परेचर, सिंपल, हमें इसका ज्यादा फिजिक्स में घुसना नहीं है, एटलीस्ट इस क्लास के लिए. जब आपका फिजिक्स हो वहां पे प्लाज्मा फिगर आउट करो टू द एक्सटेंट दैट यू वांट टू अंडरस्टैंड. इज दिस ओके? नाउ once this universe was in a plasma state, okay, because the atoms had started forming at that time, this was one thing that we get. What was the other thing that we got along with that? The other forces were, we saw electromagnetic was the field, the force was static, the charge part of the story. Okay, so electrostatic forces started giving us charges in the charge. So charge particles started existing because of this. Charges on particle, plus minus. I hope everyone understands this much of charge at least. Okay. So electrostatic force, and because of another force, magnetic force, when these two came together, they gave us electromagnetic radiations. I'll directly write field and radiation. Maybe you can write this way, field and radiation. Radiations. And these radiations we have seen, electromagnetic radiation from light to radio to gamma and all other in between. Electromagnetic radiations. Okay. Now electromagnetic radiations, obviously they travel as radiations or rays. Okay, that's how your energy travels, in the form of radiations. So thanks to this we had these, and light is also one part of the story. Okay, good. Now the third force was your gravitational force, because matter has started forming. The moment you say atom, it is basically matter. Atom to matter hi hai na. So matter we can write where we have written this thing, the first. Thanks to this, atom formed, which is nothing but matter. So one thing we got in the universe was matter. The second thing that we got thanks to these radiations and all was energy. Okay, one form of energy you can say, the electromagnetic radiation related energy, light and all this. Then we also got gravitation because of matter, and another form of energy that was there, gravitational force. Okay, and this was also another form of energy. Right, so you have charge energy, you have radiation energy, and you have energy due to matter. Just say Earth has mass and matter, and thanks to that it has gravitational energy. I hope itna sabko pata hai. Anything which has mass has some gravitational energy related to it. ठीक है ना? Okay. And then the fourth force, fundamental force that we had was weak nuclear force, which will lead to what you call as, you can say, nuclear reactions, right, or disintegrations, right? Radioactive or radioactivity is an outcome of this, radioactivity. So release of energy again happens in this, and basically here what happens is matter turns into energy. और E equals to mc square टाइप का आपने इक्वेशन सुना होगा, किसने दिया था आपको वो भी पता है, बहुतों का टी शर्ट पे लिखा रहता है ऐसा. ठीक है, तो उन्होंने क्या बोला था, simply said in the simplest language, mass and energy are convertible, right? So you can turn mass into energy, you can turn energy into mass. He also there said that mass is nothing but energy at low frequencies, right? So when energy turns into lower frequency, it gradually starts picking the characteristic of mass. इतना में हमें नहीं घुसना है, फ्रीक्वेंसी फ्रीक्वेंसी दूर फेंक दो. अभी हमें को क्या समझना है, दे आर इंटरचेंजेबल, राइट? सो योर weak nuclear forces give you the turning of mass into energy. ठीक है, जैसा सन में हो रहा है. What is happening in the sun? The hydrogen is there and it is turning into one nuclear reaction. Okay, and because of that nuclear reaction, it is also radiating energy, heat energy, light energy, all this. Is this clear? Simple सा बात है ना? I hope everyone understands. So these are the four forces because of which we get these kind of, so this is also energy, I should say B. Now, so now you have two things in the universe, matter and energy, but there are something more which makes the universe. What is that? Time and space. Okay, so when you see the space around yourself, there are two more things apart from these four forces that we have, and because of the four forces we got matter, we got what makes the universe, matter, energy, time and space. And space we wrote was the space in which everything exists, including you, me, earth, everything. So when you see the universe is made up of these four things only, separate, and all these four are separate. So mass is separate, space is separate. In space, matter is there. In space, energy also moves, travels, what all, and you calculate all that sequence in terms of, or keep record in terms of time. Okay, so that's exactly how your universe is progressing, very simply said. Which means that Big Bang started segregating these four. Okay, Big Bang se hua kya? These four started getting segregated from that one single thing which existed before Big Bang. Right? So before Big Bang we had one single thing. Your NCERT calls it as primordial atom. Okay? The NCERT calls it as primordial atom, in which everything existed. All the space, all the time, all the matter and all the energy of the universe before Big Bang existed in that one small dot-like thing. Okay? Is this clear? So if you want, you can note this. लिखें, साथ साथ लिख भी लेते हैं. So you can write that after Big Bang we see that time, space, energy, and matter. Time, space, energy and matter led to creation and evolution of the universe. By continuously expanding the universe. Full stop. This means that all these four distinct parts of the universe, were undifferentiated as one thing called as primordial atom. PRIMORDEAL, primordial atom. DIAL, not E, DIAL, primordial atom. Within quotes, primordial word you can put within quotes, primordial atom within quotes, as per NCERT. ये भी लिखना है, ठीक है, as per NCERT. ठीक है. The characteristic of this primordial atom, was that it was infinitesimally small, having all matter and energy into it, infinitesimally small, having all matter and energy into it, and hence infinitely dense, and therefore hot, infinitely hot. Some sources say the temperatures might have been as high as trillions of degrees Celsius. Okay, so infinitely hot. Is this okay? Right? This form is also called as singularity. This form is also called as singularity as per science. So when you come to this stage, somewhere here, before Big Bang, what existed? Singularity as per science, which your NCERT calls as primordial atom. Primordial means something primary, initial. Singularity means one. Right? So science calls it because all the four parts were one, therefore they call it as singularity. Okay? And this is not something very new. Okay? I find something resonating in religion also to this. Sub religion जब आप पढ़ते हो, any religion, they say there was, where does everything start from? Oneness. है ना? One. Ultimately everything turns into and came from one. तो जो religion के अंदर हम जिसको oneness कहते हैं, ओमकार, एक ओमकार, बहुत सारा word है. ठीक है? I think the reference was probably to this kind of existence. Obviously science calls it as singularity, and maybe your religions go on to give you the laws of nature that they understood. I'm not saying they identified, obviously not, but they might have, whichever way. So anyways, coming back, let us go beyond this. Now, so now we have to start the story after first 3 minutes. After first 3 minutes, till nearly 3.8 lakh or approximately 4 lakh years after Big Bang, right? So please do draw this flowchart along with me. From first 3 minutes till nearly 3.8 or nearly 4 lakh years after Big Bang, the hydrogen remained in plasma state only. First of all the hydrogen in the universe that you come across was formed in this phase. Right? All hydrogen. Right? The first reactions that took place during this period gave us all the hydrogen that you get to see in this universe, including the hydrogen that you drink in your water, H2O. आपका H2O का जो H है, वो कब बना है? 13.7 billion years before present. तब भी आप fresh water ढूंढते हो. मतलब ऐसा नहीं fresh water नहीं ढूंढना है, but all I'm telling you is part of it was made 13.7 billion years before present. Okay, after that no hydrogen is formed. All hydrogen was already formed by them, and all that hydrogen remained in the plasma state. ठीक है, right? So remained in remained in all hydrogen remained in plasma state, the high energy state. And where do you see hydrogen in plasma state? Do you have any place where we have hydrogen in plasma state still? All the stars, including sun. Okay. In all the stars, including sun, you have hydrogen still in plasma state, hot plasma state, especially where the temperatures are extremely hot, not on the surface of sun, but where the temperatures are very hot. And the characteristic of hydrogen in plasma state is that it is opaque. Hydrogen in plasma state is opaque. In gaseous state, it becomes transparent, you can see through. But till it is in plasma state, hydrogen is opaque. ठीक है, तो ये लिखना है हमें. Plasma state, hydrogen remained in plasma state, therefore opaque. And hence the universe in its first nearly 4 lakh years was transparent or opaque? Opaque. ठीक है, even the universe in its first 4 lakh years, 3.8 or 4 lakh years was opaque. आपने ऐसा लिख लिया है. If you want, you can write this line also. Right? Because all the hydrogen was in a opaque state. All the hydrogen was in a opaque state. Because it was in plasma state. Okay, all the hydrogen was in opaque state because it was in plasma state for the first 4 lakh years of the universe. In the first 4 lakh years of the universe. Good. Should we go beyond? इतना समझ में आ गया. Now we have to take the story from 4 lakh years onwards. Right? So when you talk 4 lakh years after this, nearly 4 lakh years, you can write nearly 4 lakh years before present. Sorry, nearly 4 lakh years after Big Bang, not present. 4 lakh years after Big Bang, the universe cooled enough for the hydrogen to now turn cold enough to be gaseous. Cold enough to be gaseous. So first 4 lakh it was plasma, after that it became cold enough. Why? Because it was expanding. Right? Cold enough to be gaseous. Is this okay? And when we say universe was expanding, you have to understand one very fine thing here. When we say the universe was expanding, okay, what was expanding in universe? Was time expanding? Was time expanding? We'll talk of that later. Was space expanding? Was matter also expanding? No. ये जो yes बोल दिया ना फ्लो में, हाँ हाँ सब कुछ ही yes yes. ठीक है, मैटर एक्सपैंड नहीं हो रहा था, अदरवाइज हाइड्रोजन एटम अपने आप में एक यूनिवर्स बन जाता. राइट? सो द मैटर वाज नॉट एक्सपैंडिंग. व्हाट वाज एक्सपैंडिंग वाज द स्पेस. व्हाट डज दैट मीन? एक्सपेंशन ऑफ स्पेस का मतलब क्या है? द रूम दैट यू आर सिटिंग इन राइट नाउ, इट इज अ रूम साइज. इमेजिन आफ्टर फ्यू इयर्स इट बिकम स्टेडियम with you being where you are. You are the matter, the room is the space. Do you get it? So what was expanding? The space was expanding. Right? Space was stretching. If I make you understand in 2 dimension, if you take a bed sheet, or maybe you take a hanky, right, and you stretch the hanky and make it a bed sheet. आ रहा है समझ में? So this is what we mean by expansion of space. But it doesn't mean that the objects in it are also expanding. No, the objects were not. Okay. So suppose I take a hanky and on that I put a small plastic ball, very small ball, and I make it roll. And while the ball is rolling, imagine the ball to be a galaxy. Okay? And ball is rolling, which means the galaxy is traveling in space. And imagine while the galaxy or the ball is traveling, I stretch the space. What would happen? What would happen? The space that the galaxy now would be traveling would become wider, bigger. I hope you understand. And it depends on the space at which I am stretching. If I stretch the bedsheet faster than the speed of the ball, then the galaxy can continue to travel forever. Are you understanding? The ball is traveling and I stretch the bedsheet also. And let us say I stretch the bedsheet fast enough, faster, maybe initially I am not stretching it fast enough. So the ball is traveling in space. And let us say if I continue to go on stretching and stretch it faster than the speed of the ball, what will happen? The ball will move faster. Will the ball move faster? You can say obviously to some extent. But gradually you can also say that probably the space will never end. Do you understand? Okay. Why am I making you understand all this is? Because when I'll tell you the size of the universe, your next question to me would be, sir, how come? Okay. So now please try to understand. So H2 now traveled. Okay. The H2 was now turned cold enough to be gaseous. Okay. And once it turned gaseous, it will turn into, so gradually this gaseous hydrogen started making lumps. Okay. This gaseous hydrogen, if you want you can write this. This gaseous hydrogen started making lumps. Lumps of gases. Do you see lumps of gases? Lumps of gas देखा है आपने? For example, when you go outside and see the sky, do you see some lumps of gas? You call them as clouds. देखा है ना? Clouds. So we have cloud-like formation in the universe now. But the clouds of the universe are not called clouds. They are called as nebula. ठीक है? So started forming lumps of gases, cloud-like, called as nebula. So what is a nebula? A nebula is nothing but a cloud of some gases. And these were clouds of hydrogen. Okay? Cloud of hydrogen started forming. Is this okay? What does a cloud of hydrogen look like? Can you see this? This is a real image of a nebula. Okay, though you can see light also in it, but right now I'm not talking of the light because that light is coming from stars. We are still to talk of formation of star, but can you see that nebula thing? That is like a cloud in the, and this is a real nebula image. Okay, so this is what nebulas look like in the universe. So we have started getting nebulas in the universe and we started getting numerous nebulas. Okay, as per counts, we have trillions of galaxies in the universe. And these nebulas, the bigger nebulas that we talk of, will be forming galaxies gradually. Okay. So, we started getting nebulas of the size of the size 80,000 to 1,50,000 light years. So these were nebulas as big. Okay, light year, I hope you understand, is the distance which light or electromagnetic radiations travel in 1 year. Okay, we count it for visible light, but even the other ones travel at the same speed. I told you earlier. So 80,000 to 1,50,000 light year was the size of these nebulas. Okay, hence they were big enough. They were big enough, and they were much bigger. This is the number given in your NCERT. Some of the nebulas or most of the nebulas are much bigger than this. That's not the limiting size. I'm telling you the minimum size. So this is the minimum size of the bigger nebulas that you have in the universe. Okay, and they are bigger than this also. So these nebulas are called as galactic nebulas. Galactic nebulas, as they form galaxies. Galactic nebulas as they form galaxies. Okay, is this okay? So is it also processing till now? Yes, it is. Aman, and any other question you want me to take up, ma'am? The moment you see, because many times I might miss some of those things responded by them. So in case I do, please do let me know if you want me to pick any of these questions. Okay. So galactic nebulas as they form galaxies. Now, next thing. Till now, after the hydrogen turned into plasma state, after the hydrogen turned from plasma state to gaseous state, right this way. Till now, after the hydrogen turned from plasma state to gaseous state, the universe became transparent, but was dark. Became transparent, but was dark universe. Okay, there was no light source, because light comes from stars and stars are still to form, right? So this was the phase of darkness in the universe. The whole universe was like a dark room filled with gas. Okay, and clumps of gases at different places. Imaginable? Can I say? Very good. Now, let us come to next step. Making of stars within galaxies. Making of stars within galaxy. What else will you get if you don't have a light source? If I remove all the light source from this room, what will happen to the room? Before the plasma state, but what did we write? Right? After the hydrogen turned from plasma to gaseous. लिखा है ना आपने? Before that, nearly 0 to 3 minutes, it was all energy. 3 minutes till 4 lakh, we got hydrogen as plasma, and 4 lakh to now, we have hydrogen in gaseous. Once hydrogen is in gaseous state, it cannot emit light. And for light, you need some light source. What are the light sources in the universe? वो तो बनाया नहीं अभी. So will you get light? Simple. I know, darkness is never created. Darkness you can't. You don't have a machine to create darkness. You have machines for creating light. Darkness is not the opposite of light. It is not positive ka. 2 positive is light, so 2 minus is darkness. No. There is nothing like 2 minus. Darkness is 0. Darkness is not the opposite of light. It is the absence of light. ठीक है? So don't confuse yourself. These concepts, heat and cold. Cold is not the opposite of hot. It is the absence of hot. Absence, opposite, दोनों में अंतर है. नंबर लाइन के ऊपर absence of magnitude is 0 and opposite of 2 is -2. तो अंतर होता है दोनों में. That was what you call as the, okay, so that was the plasma state thing. I'm not talking of that. I'll talk of that later. ठीक है? In the plasma state you do get, but we won't talk. I told you there are parts of this science. अच्छा आपकी क्लास में शायद बोला नहीं है. There are part of this universe story which I won't talk right now. Why? Because it is a bit too more of physics and chemistry. Second, I probably many times your science faculties also go on to cover it, right? So I'll leave this for the time being. For example, dark matter, dark energy, all those things. Okay, black holes, ये सब कुछ नहीं समझाऊंगा अभी. Wait. Okay, and the background radiations of the universe from which you come to know of the age of the universe. I won't talk of that right now. I'll talk of all this in the last class. So please don't ask me questions related to them right now. Have faith. Either your science teacher will cover. If not, by the time I complete my classes, last class I will ask you, are those topics covered? If they are not covered, you will tell me, no sir, I will cover it myself. Okay, but I generally don't start with it because then it will take me another class to explain you all that and it will become more of science, so many of you start getting bored. क्योंकि अभी आपने साइंस पढ़ा नहीं है, बहुतों ने, सबने नहीं, बहुतों ने, तो आप लोग बोर होना शुरू हो जाते हो. This is a general response that I get in the class. That sir, it is becoming too much of science. ठीक है, by students who don't have science background in recent years, right? So I have deliberately postponed it for the last class, and it is not needed in between. ठीक है, so we won't talk of them right now. Is this okay? Anything left? हाँ बोलो. One sentence, confused, बोलो. So there was light. In the first 4 lakh years there was. Initially it was only energy only. For the first 3 minutes there was no matter, only energy. अभी लिखा हमने, शायद बोला मैंने, 0 to 3 minutes, only energy. So there was light, ample light. After that, up till 4 lakh year, we did get some light. After that we had. That's why only for the period 4 lakh to now, I'm saying, is the dark age. I'm not saying the initial phase of universe was dark. Clear? हाँ जी. So should we continue? आगे बढ़े? Okay. So हाँ जी, बोलो, listening. एक और small छोटा सा आप सबसे request है. The request is that in an attempt to make it digestible by all of you, I'm deliberately, I won't say modify, neglecting and hiding some parts of science here. Okay, because if I go into those domains, then for others it becomes difficult to pick up. ठीक है, तो आई नो जो थोड़ा साइंस बैकग्राउंड वाले हैं, फिजिक्स कई बार होता है, फिजिक्स, केमिस्ट्री, इंजीनियर्स, है ना, ऑल दोज, कुछ वो बैठा बैठा सोचता है यार ये सर ने 3-4 चीजें तो छुपा ली या इनको पता नहीं है. मान जाओ मैंने बहुत रिसर्च किया इस पे. ठीक है, तो पता तो है, बट डिलिबरेटली आई रियलाइज कि सब कुछ शुरू में आपको बताना थोड़ा गड़बड़ हो जाता है, क्लास मैनेज करना मुश्किल होता है. यस, मैटर क्यों नहीं एक्सपैंड किया था, अभी आ रहा है. मैटर को ग्रेविटी होल्ड करके रखती है और स्ट्रॉन्ग न्यूक्लियर फोर्स उसको ना तो डिसइंटीग्रेट होने देता है और ग्रेविटी उसको साथ में होल्ड कर लेता है. ठीक है, स्पेस को ग्रेविटी वैसा होल्ड नहीं करती है, मॉडिफाई होती है उससे. और इसीलिए मैंने टाइम के लिए भी बोला था, डज टाइम एक्सपैंड? When you talk of the time, space-time continuum, it expands. It does modify, bend everything. लेकिन वो सब अभी बात ही नहीं करनी है हमें. ठीक है. So coming back, making of stars with galaxy. Now that you have a galaxy, galactic nebula. I hope ये galactic nebula समझ में आ गया सबको? It is nothing but a big cloud. Okay, so the galactic nebula, just imagine, is something like this. Okay, of the size few thousands or lakhs of light years. ऐसा बड़ा सा galactic nebula है. Now, what do you think is holding this nebula together? Which force of nature? Gravity. Gravity is holding the mass of the gases, is holding the gases together. If you want, you can write this. That the galactic nebula is held together due to gravitational force. This is where gravitational force starts coming into play. Okay? The galactic nebula is held together by the gravitational force. Gravitational force. The galactic nebula is held together by the gravitational force, making a clump. Making a clump which you call as the nebula. Making a clump. This clump is that nebula thing, galactic nebula. पूरा galactic nebula clump ही है ना? हाँ, इसी का बात कर रहे हैं अभी. CLU clump. अच्छा हाँ, CLUMP clump. Clump means something which you, not clamp. It is not clamp. Okay, something bunch of something. Okay, clear? Okay, now next, please see and try to understand. Further, because this galactic nebula itself is big enough, I hope you can imagine that the gravity at all the places would not exactly be uniform. Is it imaginable? You're talking of a very huge thing. On the earth itself, we don't have gravity exactly same everywhere. Right? It is 9.8, but it is not exactly 9.8 everywhere. ये सब हमने स्कूल में पढ़ा है 8, 9, 10th, hopefully. Same ways in this galactic nebula also, the gravity was not exactly same everywhere, because of which further clumps started forming within the galaxy. Wherever the gravity was slightly higher, we started getting more clumps. Clump within clump, right? Or cloud within cloud. Okay, right? So the second set of clouds will be slightly more denser. Is it imaginable? Are you समझ में? So the whole thing is, just imagine, this room is also a cloud. It is a cloud of air. है ना? And in this, let us say at some place from this ventilator, many times you might have seen that there is some kind of, that foggy thing coming out. देखा है ना? So what is that? Or when you are cooking in your kitchen, that whole room is filled with oxygen or air, and when your mother is cooking something, you have smoke coming out. Now that smoke is cloud within cloud, because your room is the big cloud and that smoke is a small cloud. Is it imaginable? So same ways in this universe also, we started getting smaller numerous clumps. We call them as stellar nebula, star making nebula. Clear? And this happens due to gravitational variations within the galaxy. Okay, there are more things behind it. I won't take you into that right now, not needed, right? But very simply said, within the galactic n dot is nebula, we started getting stellar nebulas. Stellar nebula are star making nebula, things which will turn gradually into stars. Okay, so we started getting stellar nebula, star making gases or clouds, star making clouds. Okay, now stellar is star, that word comes from star. Okay, आपने सुना होगा stellar performance. What is stellar? Star like. Okay, so now if I take you into this, what is holding this stellar nebula together again? Gravity, very simple. And thanks to gravity, the stellar nebula will start collapsing onto itself. The gravity will make it more compressed, because that's what gravity does. It tries to attract everything toward itself. And if it is not solid, if it is gas, it will try to attract it more and more. ठीक है ना, सॉलिड होता तो हार्ड होता, but it is not solid, so it will try to attract it more. When it attracts it more and more, what will happen in terms of density? The density will start increasing, and hence the temperature also, because of this contraction, forceful contraction, temperature will also, इंडिया और दिल्ली, वो इंक्रीज डिक्रीज जब आप सब मिलके बोलते हो ना तो मुझे दोनों सुनाई देता है. दैट्स व्हाई आई से आई इंडिया इंक्रीज एंड डी दिल्ली डिक्रीज. बोलो इंडिया. वेरी गुड. दिल्ली वाला तो कोई नहीं है ना, बिकॉज वी हैव दिस थिंग दैट व्हेन ऑब्जेक्ट्स टेंड टू कॉन्ट्रैक्ट दे आर कूलिंग. They are not cooling because they are contracting. They are contracting because they are cooling. That is another thing. ठीक है. So if things cool, they contract, and if you contract something, then it heats up. ठीक है. So you should be clear between these two also, because I do get this doubt. Many times people will walk to me चुपचाप से, सर जब चीजें कॉन्ट्रैक्ट होती हैं तो वो तो ठंडा होती है ना. How was this heating up? There is a difference between these two statements. When things naturally cool, they contract. So the contraction there is a consequence. Okay? And when you forcefully contract something, the consequence is heating. Right? So what is contracting this? The gravitation. Okay? Therefore, the temperature increases. Is this okay? ठीक है. Very good. Now let me put numbers to some of these temperatures. What is the temperature of the universe in general presently, if I ask you? Anyone knows? The temperature of the present universe is nearly minus 270 degrees Celsius, 2.7 some Kelvin, or 2.7 some degrees higher than absolute zero. That is the average temperature of the universe, minus 270 degrees Celsius. Okay, the average universe temperature is this, when you are including all the space of the universe. I'm not talking of galaxies. So when I talk of this space outside this galactic nebula, the temperature of this average will be minus, approximately minus 270 degrees Celsius. When you come into the galaxy, the temperature increases because the masses are held together. So within the galaxy, the temperature might be warmer, right? Maybe nearly, you can say 220, minus 220 degrees Celsius or whatever, which means it has become hotter by nearly 50-60 degrees. Okay, that is the galactic temperature. When you talk of these stellar nebulas, the temperatures initially might be something like 200 degrees Celsius, minus 200. And when this temperature reaches, when the temperature of the stellar nebula is minus 173 degrees Celsius, we say it is set to make a star. It is warm enough to now gradually turn into star, and hence the name is protostar. So when the temperature of the stellar nebula reaches minus 173 degrees Celsius, we start calling it as protostar. What is the meaning of proto? Proto is a sample, prototype, right? Initial model, right? So when the temperature of the stellar nebula reaches nearly minus 173 degrees, which is 100 degrees higher than the universe average temperature. So it is boiling in terms of your language, right? 100 degrees higher than the universe average temperature. Universe average was nearly minus 270. This is minus 173. Once the temperature is nearly 100 degrees hotter, you start calling it as protostar. Protostar is a stellar nebula which now most probably turn into a star. Is this understood? Clear? So is this diagram understood? Yes? Any doubt? Please उठाओ हाथ. मतलब ये देखो, आप लोग ना रिस्पॉन्ड नहीं करोगे तो मुझे समझ में नहीं आएगा. अगर नहीं समझ में आ रहा है बोल दो नहीं आ रहा है सर. Why did I write minus 200? I have written only for the stellar nebula to begin with. So in the initial phase, the stellar nebula itself might be nearly minus 200, but that doesn't mean at minus 200 you can't surely say it will turn into a star. At what temperature do we start calling it that this most probably will turn into a star? Minus 173. So it has to become hotter by another 27 degrees. Then only, which means the reactions have started taking place. That's why it is getting hotter. Is this clear? Okay. So I was just giving you a comparative temperature of different regions in this image. So minus 270 is average of the universe presently, not at that time, right? But gradually I'll tell you what happens. So minus 270, then within the galaxy it might be something like minus 220 or so. Around the protostar, right? Around the stellar nebula, till it has reached the protostar state, it might be something like 200, minus 200. Once it is set to become a star, the temperature must be around minus 173, and you start calling it as a, now you don't call it as a stellar nebula. Now you call it as a protostar. Is this okay? So now it is protostar. It is no more just a stellar nebula. ठीक है ना? राइट? ये ऐसा ही है, प्रीलिम्स क्लियर कर लिया इसने. अभी आप सब एस्पिरेंट हो. उसके बाद इसका प्रीलिम्स कब क्लियर होता है? minus 173 पे. Then you can say he might become a IAS now. प्रीलिम्स तो निकल गया लड़के का या लड़की का. ठीक है ना? ऐसे ही बात करते हैं ना आप लोग आपस में, या पापा मम्मी. ठीक है. सो ये प्रोटोस्टार बन गया अब. Now from protostar to star, what is the change? From protostar to star, the change is again in terms of, we measure again in terms of temperature for our UPSC purpose, because till now we have been talking in terms of temperature. तो temperature का ही भाषा में बात करेंगे. Gradually, as this protostar goes on compressing more and more due to gravity, which means it has ample matter, then only it will compress. If it doesn't have ample matter, then it cannot compress. If it has ample hydrogen, then the hydrogen, due to its mass, will go on making it more contracted, and the temperature of this might shoot to nearly 10 million degrees Celsius. The temperature might shoot to nearly 10 million degrees Celsius. This is the temperature conducive for thermonuclear reactions, what you call as hydrogen reaction or fusion reaction. The hydrogen fusion reaction. Okay. Once the temperature reaches this, in the protostar, hydrogen fusion reaction starts. Hydrogen fusion reaction starts, which is a nuclear reaction, right? And when a nuclear reaction takes place, what is the outcome of that? One is a changed atom, second is electromagnetic radiation. Okay? So when this fusion reaction, this is nuclear fusion reaction starts, it gives changed atom. What is the changed atom here? Helium plus electromagnetic radiations. So what all radiation will it give? All. And the other in between ones also. All electromagnetic radiations are released from such atom. Slow? बोर्ड? अच्छा, थोड़ा ऐसा जूम आउट कर दें, ये चलेगा? अभी दिख रहा है? ओके, यस, हाँ जी, बोलो. Of the protostar when it has further compressed and the nuclear reactions have started. ठीक है? So after protostar, the next stage that we generally talk of, there is in between stages, but we might not. will directly from proto come to star. ठीक है? Decreases or increases? कहाँ? यार आप मुझे ऐसा झटका दोगे तो है ना. अभी ठीक है, समझ गया. वो माइनस साइन भी देखना है. यस मैम. Stellar nebula concept. What is stellar nebula? Thank you. So just one more quick revision. यार इस टाइप का और कोई हिडन डाउट तो नहीं है ना? हाँ सर, ये टेम्परेचर डिक्रीज क्यों कर रहा है टाइप? अभी ठीक है. वो क्यों कर रहा है? ग्रेविटी की वजह से, क्योंकि वो कॉम्प्रेस हो रहा है इसलिए इंक्रीज कर रहा है. ओके, द टेम्परेचर इज इंक्रीजिंग बिकॉज ऑफ ग्रेविटी वर्किंग एंड कॉम्प्रेसिंग इट. ठीक है. Now, for the ones who have asked me what is stellar nebula, there are two ways. One, you can understand that part of, watch that part of the video once again yourself at the end of the class. But let me do a quick revision here. This is the hydrogen gas which has made the galactic nebula. Within it, at different places, due to variations in gravity, very simply said, due to variations in gravity, you start getting some more clumps. It is like let me tell you, रबड़ी जैसे बनाते हैं आप, है ना? So when you start mixing that milk, gradually what do you find? The milk starts getting thicker and at some places you start getting clumps, जिसको आप रबड़ी का वो भी बोलते हैं कुछ, है ना, जला हुआ या whatever. So the way that rabdi is made, okay, and at different places due to variation in characteristic you start getting clumps. Same ways when the nature is making rabdi in the galaxy, ठीक है, वो भी गैलेक्सी का रबड़ी बना रहे हैं, right? The forces are acting the same ways. So wherever there is some variation in characteristic, some more thicker elements or thicker groups might start accumulating, higher density. That's it. So that higher density thing is the stellar nebulas. So they are within the galactic nebula. I hope this is clear. Okay. Any other doubt? आगे बढ़े? Yes. So where did we reach? When the temperature in that stellar nebula first reaches -173, you start calling it as a protostar. When due to more compression, the temperature reaches nearly 10 million degrees Celsius and the nuclear fusion reaction starts. Nuclear fusion starts turning hydrogen into helium and releasing electromagnetic radiations including light. And you see this light, which is brightening up the universe, brightening up the universe. So they are the LEDs of the universe which glow at different places and lighten up the universe. ऐसा ही है ना? Is this clear? Broadly clear? है ना? As I said, please don't go into too much of physics and chemistry. Don't think of it as physics and chemistry. Just think of it as natural laws. What is happening in nature? Simple. Okay? So you start getting the light in the universe. So now the light in the universe has started glowing. So from dark universe, which started around 4 lakh years after Big Bang, to the star universe, where light again started reappearing in the universe. Is this clear? Now, when did the first stars formed? When did the first stars formed in the universe? When you read your NCERT, it says around 5 to 6 billion years before present. Your NCERT has written this line. The universe, the first stars were built nearly 5 to 6 billion years before present. That is a wrong statement. ये लिखना है कॉपी में. The first stars were not formed 5 to 6 billion years before present as stated in NCERT. Wrong statement. The first stars were not formed 5 to 6 billion years before present as stated in NCERT. That is a wrong line in NCERT. ठीक है? The first stars were not formed 5 to 6 billion years before present. They were formed. They were formed within few 100 million years. We don't exactly know which 100th million year, but within few 100 million years of Big Bang. Within few 100 million years of Big Bang. Right? And definitely within first billion year of Big Bang. Definitely within first billion years of Big Bang. How much is a billion? 1000 million is a billion. So when we say few 100 million, right, let us say 400, 500 million years after Big Bang, the first stars were formed. So that were obviously within first 1 billion years. So within first billion year of universe, definitely stars were already formed. Right? So if you see the oldest stars in the universe, they would be nearly 12.7 billion years or 13 billion years old. Right? You might not find those stars. Something would have happened. I'll tell you. You will gradually understand what has to happen to them. But the oldest stars in the universe would be nearly 13 or 12 billion years, not 5 or 6. Clear? Is this okay? So within the first billion years or nearly few 100 million years, you started getting light. So if I ask you, what was the period of this dark age? Dark age. Dark universe. 4 lakh years before, 4 lakh years after Big Bang to up to, you can say few hundred million years. So how much time did those stars take to form? It took those hundreds of million years to form. It was not an overnight process. Right? From galactic nebula to stellar nebula to protostar to star. The cycle was for a few 100 million years. Right? It's not that just after 4 lakh years, 5th lakh year you already had a star. No. It was not a 1 lakh year process. It was not a 1 million year process. Few 100 million year process. Right? From galactic nebula to star. Right? And all this while the universe was further cooling also because it was expanding. So the universe was cooling, but at the stars it was heating up. Clear? Is this okay? Can I give you an example of this kind? The earth is cooling, but wherever you start getting volcanoes, those places are heated up. Yes or no? So both can happen simultaneously. The earth is cooling, but the places where you get volcanoes, those places are heating up. Simple. The same ways. The universe was cooling, but wherever the stars were forming, those places were heating up. Is this okay? So gradually by cooling, the universe has come to that number of minus 270 degrees. Presently the temperature is minus 270, and in the stars the temperature would be few tens of millions of degrees Celsius. Simultaneously. Two different set of processes happening. Universe is expanding, gravity is making the stars contract and become hotter. Clear? Aage badhe? Okay. Very good. Now why did I make this star for you? Did I make it for the purpose of just making a star? No. There is something very important. Along with the light, all the other radiation, the way. For example, from the sun, what all radiations do we get? That you know at least. Do we get light? Do we get UV radiation? Who stops the UV radiation or what stops the UV radiation? Ozone stops. Okay? Yes or no? Do we get radio waves from the sun? We do get. Okay? We do get radio waves from stars also. Right? Infrared. Do we get infrared? The heat coming from the sun is infrared. Heat. Radio waves don't harm us as such. They are very weak. The higher energy ones would harm you, such as the ultraviolet, the X-rays, the gamma rays, but they are already protected. We are protected. That's why you are here. अपने बारे में इतना नहीं सोचना है. आप हैं तो किसी ने बचाया हुआ है, नहीं तो होते नहीं. ठीक है? ओके, किसने बचाया है? दैट प्रोसेस यू हैव टू अंडरस्टैंड. ओके, सो वो बेचारा घबरा गया, ये क्या हो गया, गामा रे भी आ रहा है, एक्सरे भी आ रहा है ना. यूनिवर्स टुक 13.7 बिलियन ईयर्स टू मेक यू. यू आर इंपॉर्टेंट, डोंट वरी, है ना. एंड इट हैज क्रिएटेड द होल यूनिवर्स टू मेक यू, सिर्फ आपको बनाने के लिए. होमो सेपियंस आप मतलब, ठीक है, सिर्फ अपने बारे में नहीं सोचना है. ऑलराइट, सो कम बैक. So basically now the next thing which is very important, I hope you remember when we were talking of the building blocks of the universe. हमने बात किया था ना building blocks. What are the building blocks of the universe? All the 118 elements. And till now what all have we made? अभी तक क्या क्या बना चुके हैं? Hydrogen and, but where are the others? अभी तो बहुत सारा है. Periodic table is full of elements, है ना, right? So when you see this periodic table, we have already made hydrogen and helium. All right, hydrogen and helium. But where are the other elements coming from? Because before I tell you the earth, I have to tell you how these elements are formed. Otherwise your question will be, sir, where did they come from? पूछोगे ना? The answer is, all these elements up to iron, all the elements up to iron are formed in the star by fusion reaction. So first hydrogen to helium, then helium to, next goes on carbon, oxygen, nitrogen, all the elements up to iron, right? So as per our present understanding, all the elements up to iron are formed in the stars only due to consecutive fusion reactions. So hydrogen to helium, helium to next, next to next, next to next, and they go on fusing up to iron. In this process, the temperature in the star also goes on increasing, right? So 10 million is good enough for hydrogen fusion. It is not good enough for iron fusion, right? For helium fusion, once the fusion will happen, that will make it more hotter. Once it becomes slightly more hotter, next helium fusion, then next fusion, and then gradually it goes on fusing up to making iron. So up to iron. Now this is one line I want you to write, and then if you want to figure out, अपने आप ढूंढो, ठीक है. 3 alpha reaction process है, वो सब आपको खुद ढूंढना है, मैं नहीं बताऊंगा, यहां जरूरत नहीं है. So reactions are not important in geography, the processes, ठीक है. So we write here all the elements from helium, all the elements from helium up to iron, from helium up to iron. Where is hydrogen made? Big Bang. Where is helium made? In the star. Where is up to iron made? In the star. ठीक है. From helium up to iron is made in the star, due to fusion reactions, due to consecutive fusion reactions. Okay. Due to consecutive fusion reaction. Sir, how did 10 million degree Celsius temperature happen? The 10 million degree Celsius temperature is due to the gravitational contraction which is happening in the stellar nebula. The stellar nebula goes on contracting further, okay, Nidhi, and as it goes on contracting, the temperature becomes hotter and hotter, because it is like pressing something. When you press something too close, things get hotter. That's a characteristic in physics, okay, of matter. So because they are compressed more and more, the molecules come closer, they interact, hit faster to each other and more frequently, so they get hotter. Simple. Now, so coming back up to iron everything is made in star, but अभी भी बहुत कुछ बाकी है, ठीक है? And what happens to the star? And then how are planets born? ये सब भी समझना हमें. So first of all, for planets we need all the elements. If you have all the elements, then you are ready to make the planet like Earth, because on the Earth we find most of the elements, ठीक है? And then gravity will do its own work after that. But first you have to have all the elements. Now the next part of the story. The next part is that once these stars, I think हमने इसमें star भी बना लिया कहीं ना कहीं. Yes. So this whole thing is what you call as a star, because it is emitting light. ठीक है? So star is formed, and in the star, from helium to iron, all the elements are formed. But gradually what will happen is that in this star also, first of all, beyond iron the temperature never reaches in the star, right? Beyond iron the temperature never goes higher than fusing iron. It is never high enough to fuse iron also in the star, right? This is a characteristic with the biggest stars also, that even in the biggest stars the temperatures never go higher than making or fusing iron into the next element, right? Hence the fuel is over. The star was producing its own fuel. It was turning hydrogen into helium. Now helium was the next fuel, okay? And then from helium to carbon or whatever, and carbon to whatever up to iron. So up to iron it was making fuel. But once it reaches iron, now it is not big enough to burn or fuse iron, which means it doesn't have any more fuel. When the fuel in the star ends, and especially it ends in the center of the star first, because that's where the reaction started, right? In the center of the star the reaction would have started, so the fuel in the center gets over first. So gradually what would happen is that if this is the star, the fuel in the center is over, fuel over, right? So nuclear reaction, NR is nuclear reaction, stops in the center, whereas on the sides reaction, nuclear reaction continues. In the center the nuclear reaction stops because the fuel is over, right? Because it has already used all its fuel, whereas on the side the nuclear reaction is still on. This destabilizes the star. The star becomes destable because the center starts cooling and contracting, and the outer part keeps warming and expanding, right? So just imagine the center is contracting and the outer side is expanding. What will happen? The star becomes unstable and it explodes. This is when the star dies. This is called as the death of the star. Is this understandable? So in very simple language, if you don't want to write other things, all you can write is when the fuel in the star gets over, the star dies by exploding. Death of star तो सुना ही होगा, fuel नहीं सुना होगा, but death of star तो सब नहीं सुना है ना. Even stars die, है ना? So even a star would die this way, right? After living its all life, after burning all its fuel, the star also dies. How does it die? The star dies when the fuel in the star is over. Fuel is the material which can cause fusion reaction. Fuel यहाँ पे oil नहीं है, ठीक है? When the fuel in the star, the nuclear fusing material is over, the star dies when the fuel in the star, within bracket, the nuclear fusing material comes to an end. The star dies when the fuel in the star, the nuclear fusing material comes to an end. Okay? Yeah. Is for hydrogen to fuse. Helium will be slightly higher and it will continue. Contracting due to gravitation, and fusion was releasing energy. The fuel is over at the center, as we saw, and on the side the fusion is continuing. See, gravity holds after a certain point, it becomes a equilibrium where the gravity will contract it and the heat will expand it. When it hits that dynamic equilibrium, it becomes a stable star. Okay. Now, when the center heating gets over, gravity predominates in the center, right? So because of that, it will collapse the center, whereas the side body will not collapse. Okay. And the side body, due to the variations in gravity which will be created along with the heat, makes it unstable and hence it explodes. Was that your question, or the question is somewhere else? The temperature is increasing due to forceful contraction as well as the nuclear reaction now, both. Yes, on the sides. On the sides, not in the center. Yes. Yes. Okay. And once the explosion is there, then the things have expanded. So the fusion is also over. Okay. Clear? Hanji. सी रेडियो एक्टिव एलिमेंट्स का रिएक्शन दूसरा होता है, वो फिजन रिएक्शन होता है, ये फ्यूजन है. फ्यूजन रिएक्शन इज क्रिएटेड व्हेन सिंपलर एटम्स जॉइन टू फॉर्म बिगर एटम्स, लाइक इन द सन. हाइड्रोजन इज नॉट रेडियो एक्टिव इन जनरल, उसका आइसोटोप्स का मैं बात नहीं कर रहा हूं. ठीक है, हाइड्रोजन इज नॉट रेडियो एक्टिव बट इट फ्यूजेस एंड फॉर्म्स अ फ्यूजन रिएक्शन. ठीक है, सो फ्यूजन रिएक्शन के लिए यू डोंट नीड रेडियो एक्टिविटी, राइट? रेडियो एक्टिविटी इज द प्रोडक्ट ऑफ द फ्यूजन रिएक्शन व्हेन लाइट इज एमिटेड. ठीक है. अच्छा, इससे ज्यादा फिजिक्स मत पूछना यार, अभी मत पूछना. जिसको पूछना होगा ना, सब लिख के रखो. क्लास के बाद मैं इधर ही रहूंगा. मैंने पिछला बार भी बोला था, आई विल बी द लास्ट वन टू लीव. बट जब आप लोग ऐसा क्वेश्चन पूछते हो ना, आप तो खुश होते जाते हो, और जो लोग साइंस से उतना कन्वर्सेंट नहीं है, भूल गए, वो कहते हैं यार ये क्या कर रहे हैं सर, है ना. अब सर आज फिजिक्स भी पढ़ा देंगे, फिर ग्रेजुअली थर्मो न्यूक्लियर रिएक्शंस भी सिखाएंगे हमको, फिर हमारा साइंस का क्लास हो जाएगा. ठीक है, इसीलिए मैं जानबूझ के अवॉइड करता हूं, प्लीज. ठीक है, तो चलेगा इतना. जो मैं समझाना चाहता था उतना समझ में आया नहीं. पहला चीजों को ना सिंपल तरीके से समझना है, जैसा प्रेप का बच्चा समझता है, राइट? यू हैव दिस यूनिवर्स स्टोरी बुक्स इवन फॉर क्लास सेकेंड, थर्ड, फोर्थ स्टूडेंट्स. देखा आपने? वो छोटा बच्चों को भी समझाते हैं कि स्टार वॉज एक्सप्लोडेड. वो ज्यादा क्वेश्चन नहीं पूछता है. तो अभी आपको भी पहला वो लेवल पे समझना है, उसके बाद ग्रेजुअली एडअप करना है. ठीक है, फोर्थ नहीं, मे बी 7th, 8th, 9th, 10th का लेवल पे अभी वहां समझना है. 11th भी चलेगा. ठीक है, बट बहुत ज्यादा फिजिक्स में अभी मत घुसो. Is this okay? Can I go beyond? Pakka? Right? So, yes, bringing you here. So, from the star, in the star, all this was formed and the reactions were taking place and the star was continuing. Then, star, ये board, okay, let me, right, so let me write here, star starts to die. The star starts to die. ठीक है. How does the star starts to die? When it starts to die, it starts exploding. Right? I'll directly write this. Is this okay? Right? The star starts to die and if it is big enough, please do write, and if it is big enough, it explodes as a supernova. Only if it is big enough, it will explode as a supernova. If it is small, it will not explode. Something else will happen, we'll talk of that later. ठीक है, white dwarf, black dwarf, neutron star, वो सब अलग है. We won't talk of all that. ठीक है. If it is big enough, if the dying star was big enough, it will explode as a supernova. So supernova is an explosion. Is this okay? Right? It explodes as a supernova. Supernova is a prominent explosion in the universe, right? Which you can clearly see with telescopes, right? And it is said that when a supernova explosion takes place, the energy released in those moments of supernova is as much and many times higher than the energy the star would have released throughout its life, right? It is such a big explosion, right, that it can, in the moment of supernova, it releases energy more than it has released in its lifetime. Now you might ask me why. Sir, how is this possible? This is possible because in those moments it is creating those higher elements. Right? All the elements of the periodic table beyond iron, right, including all the radioactive elements, are created during supernova explosion. It becomes so hot because the fusion reactions become faster in those explosions, which goes on to increase the temperature up to the level of creating the highest level of element, right? So all the elements of your periodic table, iron onwards, यहाँ iron तक हमने बनाया था अभी, okay? When you talk of all the other elements of the periodic table going beyond iron, all this, right? I won't touch the last few elements because some of those are artificial elements. We make them in the lab. I think the last 3, 4, 5 elements, I don't exactly remember, are made only in the lab. They don't naturally occur. Leaving those in the 118, all the other are created in supernova explosion. Okay. Creating all other higher naturally occurring elements. I am writing naturally occurring because, as I said, the artificial ones are made only in the lab. Okay? All the elements, including those radioactive elements. Okay? Is this okay? Good. So in the supernova, by the end of supernova, right, when the supernova will end, what all elements will you have in the ashes of the supernova? You will have all the elements of the periodic table. Is this clear? Almost all. Okay. Now you might ask me, sir, does the hydrogen and helium completely get burnt? No. The hydrogen and helium do not completely get burned. Let me give you an example. You will understand with that. When you go to the sun, what is the temperature of the sun at the center? Around 15 million degrees Celsius. When you touch the surface of the sun, the temperature is 5000 degrees Celsius. Which means the surface of the sun at 5000 degrees is not hot enough for fusion reaction. Right? So there is hydrogen on the surface of the sun, and when you get slightly deeper, it will go on increasing. So 5000 to 6000 to 7000, and only when you come close to the core and slightly outside the core, the temperature is around 1 million or 10 million. That's where the fusion is taking place. The rest is not fusion. The rest is the heat and the gases and the plasma hydrogen. So that plasma hydrogen never turns into helium. Even if the sun will explode, the hydrogen on the outsides will never fuse. So even when the star dies, the hydrogen is not fully end. Right? There is always hydrogen in the dying star also. Right? It was like the coal which was never lit up. ठीक है ना? Is this okay? Understandable? ठीक है? So neither the hydrogen nor the helium will ever be completely fused. Okay, the reactions are only mostly taking place in the center and slightly around them, but not in the whole star. Clear? Because no star surface temperature is millions of degrees Celsius. And how do you come to know that? From the light that they emit. Right? From the wavelength of the light, you can figure out what is the temperature of the surface from which it is emitted. ठीक है, ये science है again. So you don't have to get into it, but all you have to remember is that the surface of the star is never surface and deeper also, maybe up to half the depth. The temperatures are never hot enough for fusion reaction. Most of the fusion is taking place in the interior parts. Okay, interior and middle interior. Clear? Understood? So hydrogen will still be there even after fusion. Okay, after supernova, still hydrogen will be there, still lot of helium will be there. Is this clear? आगे बढ़े. I said this because the next thing that I am going to make, you will ask me this question, sir, where did the hydrogen come from again? ठीक है? So, what do we write? Next point. Yeah, bolo, listening. It is what? The star? Come again? It was big enough, so it exploded. Therefore, it has exploded? Or are there more reasons to it? That's what you're asking? See, when you go into the size of different, there's the Vision IS handout that I asked you to read, the first handout. In there, in that chapter, you have a part known as life cycle of a star. Okay? In that life cycle of a star, you come to see that when a star dies, depending on its size, right, it takes different possibilities. If it is very small, it will turn into dwarfs, right? If it is slightly bigger, it turns into something else. Now, what decides the size, and who decided that size? There was a Indian scientist only by the name of Chandrasekhar, after whom the word Chandrasekhar limit is given. The Chandrasekhar limit is the limit of stars. Which size star will turn into what? He categorized based on many more factors. So you are basically asking me the factors of Chandrasekhar limit. Okay, I told you big enough. How big enough? You can say up to 3 times the size of the star and the sun, right? 2-3 times size of the sun. Those stars will generally turn into supernova explosion, right? The Chandrasekhar limit exactly is 1.44 for supernova. Okay. Now, how did Chandrasekhar fix that 1.44? Those are the other parameters which is not part of geography. So you can just Google and find how did Chandrasekhar fix the limits. You will get the answer. Okay, not part of geography, so I'm not touching. Okay. आगे बढ़े. Okay. Now, you people are asking me these questions, and deliberately in the first 2-3 classes I'll go on answering. Gradually, after a while, I'll start saying not relevant. ठीक है? Prepare yourself. शुरू में मैं आंसर दूंगा, बाद में क्या बोलूंगा? Not relevant. And not relevant is also an answer. ठीक है? If you still feel the relevance, go and Google yourself or meet me after the class. Right? Starting में मुझे इसलिए बोलना पड़ता है, नहीं तो आप लोग ही डाउट करने लगते हो. टीचर को पता भी है, हाँ ऐसे ही गोला फेंक रहे. ठीक है, तो शुरू में थोड़ा गोला फेंकना पड़ता है. ठीक है, लेकिन वो जो गोला है ना, वो दूसरों को जलाता रहता है. जितनी देर में आपको आंसर दे रहा हूं, बाकी सब जल रहे होंगे. क्या बकवास क्वेश्चन पूछते हैं और क्या बकवास, और पीछे वाले को तो सुनाई भी नहीं दिया क्या आंसर दिया है. ठीक है, सो देयर आर लिमिटेशंस इन अ क्लास व्हिच वी हैव टू फॉलो, राइट, एंड ऑल ऑफ यू हैव टू ट्रेन योरसेल्फ ग्रेजुअली फॉर इट, राइट. सो even during supernova, please do write, even during supernova explosion, and later all hydrogen, helium, etc. have not fused fully, right? Even during supernova explosion and later, all hydrogen, helium, etc. have not fused fully. Hence, the remaining unfused elements, right, the ones which have not fused up to the last stage, right, such as hydrogen which has not fused, helium, carbon, nitrogen, all of this, oxygen, iron, copper, the ones which have not further fused, because some of them have further fused, some of them have not fused. Unfused elements go on to form a new nebula. They will again turn into gaseous form. Okay, so some kind of big gas they will form, again turn into a nebula, now having all elements of periodic table. Now having all elements of periodic table. So now in this nebula you have all the elements of periodic table. Hopefully we understand how. Clear hai na? Okay. This is big. Now this nebula is formed after the death of what? Galaxy, star or planet? Star. So what should be the size of this nebula still? And the total mass nearly, even if some light is emitted, the mass of that remaining nebula will still be the size of a galaxy or a star, nearly star, maybe a smaller, or as small as Earth, a planet. Kya lagta hai? It will still be a stellar nebula only. Do we get it? The size of that nebula will still be of a stellar nebula. That's what we are about to write. Clear? So, this is still the size of stellar nebula or star forming nebula. Stellar nebula, it is still the size of a stellar nebula. Okay, though it has higher elements also in it now. Okay, one. Second, now there is a bit of, I should say again, general observation that I want you to bring into play here. If I give you an object and different shaped object, and if I ask you to throw them in air, okay, and let's say you throw 10 things, what is the possibility that all of them will go without rotation? What is the possibility? Very less. Because the moment anything tends to travel, because of its center of gravity being not exactly uniform, because the shape is not exactly uniform, it tends to spin. Okay? So this is a general characteristic of object. Forget the center of gravity, forget the shape, everything. Okay, just keep in mind that it is a general tendency of objects which are not exactly perfectly uniform to spin when they travel. Okay, when they travel relatively freely, they tend to spin, which means they tend to rotate. Is this okay? The same applies on objects of the universe also. When a galaxy is traveling, it tends to rotate. Okay, even when the star would be traveling, it will tend to rotate to begin with. And once the rotation has started, you need very high friction to stop it. So once rotating, almost always rotating. Okay, until unless other forces stop it from rotation. So what I want you to understand from all this last 1 minute conversation is that objects tend to rotate when they are traveling relatively freely. Is this okay? Spinning is a natural character of objects. Is this digestible? थोड़ा डाइजेस्ट हो रहा है. आप एक बॉल लो और उसको फेंको, ठीक है, या रोटी लो उसको फेंको, या कुछ भी लेके पिज्जा लो फेंको. नहीं, पिज्जा मत फेंकना, सामने कोई होना चाहिए, नहीं तो वेस्ट हो जाएगा. ओके, सो समथिंग, यू नो, when you take anything and throw, it tends to slightly spin. The same ways objects in the universe are also spinning. Okay, and spin gives the new character of object. When you tend to spin something, the heavier things tend to go out and the lighter things come to the center. This is the spin's character. कोई भी spin करके कोई भी चीज फेंको, the heavier will go out. आपने स्कूल में वो centrifuge experiment किया होगा. Test tube in the machine and you try to spin it. When you spin it, the heavier parts go to the outer edge. Okay, that's exactly when you tie a ball to a string and you try to spin that stick, the ball tends to go out. Okay, so this is a general character that heavier things tend to go out. Now come back to this stellar nebula. The stellar nebula, which is part of the galaxy and it is also traveling in the galaxy, it is not static in the galaxy. Do you think it should spin? It is one of the objects in the universe. So even this will tend to spin. When it will spin, what will happen to the heavier parts, such as the heavier elements? They will come to the margins. And what will be at the center? The lighter. What is light? Hydrogen. You get? So gradually what will happen in this new nebula? The hydrogen will start concentrating at the center and the heavier elements, slightly heavier, might go to the margins. Okay? So do you see segregation within this? Material is slightly segregating. The heavier ones will go on to form what? The planets on the outskirts, and at the center what will we get in the system? Star, like the sun. Slightly imaginable. ठीक है ना? So this is a very simple way of making you understand that how the planets are not at the center and the star outside, because the star is made up of lighter hydrogen helium type of material, right? Whereas the planets are made up of relatively heavier elements such as carbon, nitrogen, oxygen, other, you know, and then the solid ones are made up of iron and other things. Is this okay? And after that the gravity will again come into play so as to attract, because gravity is also attracting, keep this in mind. ठीक है, तो यहाँ दोनों forces है. One is trying to make things go out, the other is trying to keep things to the center, and thanks to that that system becomes stable. ठीक है, the solar system is stable. ठीक है ना, the sun is in the center, the planets are neither going out nor coming in, they are almost stable and they are just spinning. Right? So what is making the whole system stable? The spin, hence the centrifugal force. The outgoing force is called as centrifugal force. So the spin is giving the centrifugal force and the gravity is giving the inward attracting force. Because the whole system is in equilibrium, hence stable. Okay? So the planets are neither going to out nor going to in, and at the center you have the star. Is this okay? So in the stellar nebula, what would happen? Suppose this is the boundary of the stellar nebula. So in the center, you will start getting the sun type of formation, the star type of formation, right? So what will I get in the center? I'll get in the center the star type of formation, right? Maybe bigger, थोड़ा और बड़ा बना लो, star, आपको ऐसा, ठीक है? So in the center you have the star, and around the star you might get some rotating objects. Okay. And initially these rotating objects will also be something like a nebula. The way in the galaxy you have the stellar nebula, in the stellar nebula you will have the planetary nebulas. वैसा ही होगा ना? But gradually all the lighter element will concentrate in the center and the heavier ones on the side. So gradually the whole thing will turn into again a system of star planets. Clear? So this is how gradually the star and planet system is formed, with the planets revolving around the star. Broadly, do we understand? So now you have the elements, you have the broadly, you have the forces, not exactly. I again say it's not exactly as simple. Okay, but broadly we understand this. Yes or no? Okay, so should we write? लिख ले? Yes dear, बोलो. हाँ? Just give me a moment. आपसे पहले इन्होंने हाथ खड़ा किया है. हाँ जी, बोलिए. The formation of Milky Way galaxy. वो तो गैलेक्टिक नेबुला में बन गया ना. Milky Way is a galaxy. गैलेक्टिक नेबुला वहीं बन गया था वो. ठीक है. अच्छा. You might ask me the question here. One question before you ask me something. It could be that, sir, that way the heaviest planet should be outside. Which is the heaviest planet in our solar system? Out of the 8 heaviest, I'm not saying densest. Jupiter, Saturn, Uranus, Neptune, they have much bigger mass. Actually, Jupiter alone has the highest mass. Right? If you see the solar system, except for the what you call as the extrasolar mass of the solar system, half of it is in Jupiter. And only half is divided amongst others. Right? Here, because that's exactly why I said it's not so simple. Because then you have to factor in how strongly the sun's gravity is able to pull the Jupiter. Okay, so centrifugal is one force, but sun's gravity is also there. So that will locate the planets, right? And there would be more things which you read in astrophysics. So let me not go there. Okay. And to be very honest, even I have not gone to a very much, depth beyond a certain point, because I don't have interest. Because then it turns into equations only. Right? So I have not solved all those equations, but I have read. If you want, you can discuss after class. Right? Up to a certain limit, and then I can pass you on to books which will give you all those equations to solve and figure out. Okay? Yes. Anything else?
Can we say that our solar system is also a result of any star which is exploded?
Yes. उसके बिना बनेगा ही नहीं ना. ला रहे हैं उस पे. इसीलिए तो स्टोरी बनाई. आपने मूवीज देखा होगा, स्टार्टिंग में ही उसका क्लाइमेक्स दिखा देते हैं, उसके बाद पूरा पिक्चर दिखाते हैं. तो अभी आपको क्लाइमेक्स दिखाया. ठीक है, लिखें. शुड वी एनी अदर मेजर डाउट? अच्छा, हाँ, बोल रहे हैं तो बेचारे को ना, हर बार लेडीज फर्स्ट अच्छा नहीं लगता, नहीं तो फिर वो भी जेंडर बायस हो जाता है. The stellar nebula formed after explosion is big enough the stellar nebula explosion. देखो mass के terms में बात करते हैं. So when you had the first star, it had some mass. When it exploded, only a very small portion would have been radiated as light. So most of the mass still remained, and that was mass of the different elements. So that was good enough to form another star ना. अगर एक स्टार 100% था, दूसरा 80% पे भी तो एक छोटा स्टार ही बनेगा ना, है ना. जैसे शाहरुख का बेटा भी स्टार ही बनेगा, वो कुछ भी खाए पिए. ठीक है. तो मतलब समझ गए ना आप मैं क्या बोलना चाह रहा हूँ. हाँ जी बोलो. प्लैनेटरी ऑब्जेक्ट्स अलग हो गए, लेकिन पार्ट ऑफ द सिस्टम ही है ना स्टार सिस्टम. तो वो उतना बड़ा स्टार नहीं बनाएंगे. दे विल नॉट मेक एज बिग अ स्टार obviously, because some mass is getting emitted as light, some is turning into matter, planets. So obviously the next star would be smaller. That's why sun is not the biggest stars in the solar system. It's not even a moderate star. It is a small moderate star. ठीक है? Any other? बोलो बोलो, listening. Sir, you said. मैंने पिछली बार ही बोला था. Everything I only say in the class. हाँ बोलो. Anything heavier density, let us talk this way. Heavier density goes outwards, yes. Lighter ones tend to come slightly inwards. अर्थ का केस के अंदर ग्रेविटी और सेंट्रीफ्यूज दोनों है, ठीक है, तो उसका ग्रेविटी स्ट्रॉन्ग इनफ है एज कंपेयर टू इट्स सेंट्रीफ्यूज, ठीक है, ग्रेविटी यहां ज्यादा स्ट्रॉन्ग है। अर्थ अगर यही अर्थ और तेजी से स्पिन करने लगे और बहुत ही ज्यादा तेजी से स्पिन करने लगे तो उल्टा हो जाएगा कहानी, ठीक है, ओके। और कुछ? I can understand the curiosities and that's why I'm giving you these first 2 classes, 3 classes to go on asking. जो पूछना है पूछो। Why nuclear fusing material ended? Nuclear fusing material never ends. It's the condition. कोल नहीं खत्म हुआ, पानी पड़ गया। See, that's what I was trying to tell. Why did the star form in the first place? Did it form because of hydrogen or did it form because of gravitational compression which made the temperature so good enough to make it fuse? What do you think? It was hydrogen or the compression and the temperature? Right? So when the compression and the temperature made it fuse, the fusion kept the temperature high, but after some point the temperature got over. Sorry, the fusion got over because the fuel was over in the center. Maybe it has already turned into most of the higher elements and the highest possible element which was iron, ठीक है। अब आयरन से ऊपर क्या बनाएगा बेचारा, उतना टेम्परेचर नहीं है, it doesn't have the temperature, so what will happen to the fusion? End. You are answering yourself, ठीक है। तो ऐसा end हुआ, the end happened not because the material got over, as in it couldn't fuse. It could fuse provided the gravity was much more bigger. But if the gravity was that big, then it won't turn into a star. It will turn into a black hole. तो स्टार ही नहीं बनेगा बेचारा, तो कुछ और बन जाएगा, ठीक है। So stars have a limit. Star is not the biggest and the densest thing in the universe, right? You have much denser things than star and much bigger things than star, like the black holes, right? Or the neutron stars. It is said a spoon of neutron star could, have its total weight equivalent to a part of the earth. So things are so dense in the solar system, in the universe. हाँ जी, और कोई क्वेश्चन है आपस में तो नहीं है? यहाँ कोई रेडियो चल रहा है क्या? ब्रॉडकास्ट तो नहीं था ना पक्का? यू हैव अ क्वेश्चन? अच्छा, वो साथ वाले को ब्रॉडकास्ट कर रहे थे पहले। I'll come to you. Yes. Sun's gravity. Sun's gravity, okay, is bigger than. Go on asking. Yes. What? The sun? Hydrogen. Yes. See, हम ना ग्रेविटी को इमेजिन थोड़ा अजीब सा करते हैं. वी थिंक ग्रेविटी इज ओनली एट द सेंटर. आप सोच रहे हो सन का सेंटर पे ग्रेविटी है? नहीं, मास पूरा का पूरा ग्रेविटी क्रिएट करता है. अर्थ का सेंटर पे ग्रेविटी नहीं है, अर्थ का मास की वजह से अर्थ का ग्रेविटी है. ठीक है, it is the mass which gives the gravity. It's not the center where there is something hidden which is creating gravity. Gravity is a mass related force. More the total mass, more the gravity. So the gravity at the center of sun might be less than the overall gravity of the sun. क्योंकि sun का center पे there is little mass ना. But what is holding the solar system planets together? The total mass of the sun. अभी थोड़ा समझ में आया क्वेश्चन? ठीक है, so don't imagine gravity as something at the center of something. It is at the whole mass is creating the gravity. Total mass का gravity है. ठीक है, और कुछ? Do the position of the planets and planets in our solar system, let us generalize to all star systems. Do the position of the planets in any star system depends on the density and the mass and density. I won't say exactly. We are planning to dump our waste in universe नहीं, अभी तो solar system में ही कर पाएंगे हम. In the solar system. Okay. So will it shift the position from sun? Okay, very interesting question. If you ask in infinitesimally small amount, yes. Because you are taking away the mass of the earth away from the earth. So anyways divide any mass into two masses, the gravity, related gravity would change. है ना, पहले m1 था, अब m1 m2 बना दिया आपने, है ना, तो ऑब्वियसली कुछ तो चेंज होगा, बट इट विल बी इनफाइनाइटेसिमली स्मॉल बिकॉज वी आर स्टिल नॉट जनरेटिंग एज मच गार्बेज सो एज टू बी सब्सटैंशियल विद रिस्पेक्ट टू अर्थ्स मास. हाँ, सो दे सी एवरीथिंग, anything and everything, even the ice at the Antarctic has its own gravitational anomaly. ठीक है, if it melts it will change the gravity of the earth at different places, but they are very negligible, not relevant for us for our calculation. They are relevant only for very high level, more accurate calculations that we need to make. So will it to a very small amount? Yes, as per the principles of science. Is it substantial for us? Will it worry us? No. It shouldn't be a matter of concern in near future. ठीक है, and we always weigh near future versus, है ना, तभी हम कोई भी डिसीजन लेते हैं. नियर फ्यूचर में बेनिफिशियल है, बहुत लॉन्ग टर्म है तो वी से ओके वील फिगर आउट अनदर सॉल्यूशन दैट टाइम, बट लेट अस फाइंड अ आंसर राइट नाउ. जैसे अभी कोविड का वैक्सीन है, we only know near future it will save us, long term what will be the effect we still don't know, but we are saying कोई बात नहीं, अभी तो बचे, तब तो बाद में इंजेक्शन का जरूरत पड़ेगा. ठीक है, so that's how we generally weigh. Okay, और अभी आप लोग थोड़ा ज्यादा बियॉन्ड से बियॉन्ड जा रहे हो. I have to give you hints, है ना, that is also my task, not only answering you. I have to keep telling you that you are going slightly beyond. ठीक है, most of the answers that I got they were going slightly beyond. UPSC will not ask you any of these answers that almost all of you have asked me in the last few minutes. Was there? No, it wasn't fuel only at the center, it was the first place where the fuel started burning. First place. तो पहले वहां स्टार्ट हुआ तो खत्म भी वहीं पहले होगा. ठीक है. Is the sun also rotating? Is that the question? Is that the question? Yes, it is. Sun is also rotating. There is nothing which is stable in the universe. Everything is almost rotating. Speeds are different. And sun is not one solid. So different parts of the sun are rotating at different speeds. ये भी नया चीज है. ठीक है? The whole sun is not rotating at the same speed. The center is rotating faster. The ends are rotating slower. Because it is gas. It is not one solid. ठीक है, गुड इनफ. थोड़ा शांति हुई, आत्मा को तृप्ति पक्का होनी चाहिए, मतलब ना, इतना पैसा देके आए हो यार. इतना पैसा मैंने दिया होता तो मैं पूरा दिन पकड़ करके गले में लटक गया होता. ठीक है, परफेक्टली फाइन. शुड वी गो बियॉन्ड? ब्रेक चाहिए? हाँ सर, इतना क्वेश्चन आपसे पूछा है, ब्रेक तो बनता है ना, हमारा ब्रेक बनता है, ले लो. बाहर जाइए, वहां पे ना वो होगा कोई स्टाफ, उनको बोलिए फैन ऑन कर दिए. You have some questions? क्लास के बाद पूछो. अच्छा हाँ, बोलो बोलो बोलो, थोड़ा दूर रह के. मैंने पिछली बार ही बोला था. क्योंकि मैंने मास्क नहीं पहना हुआ है।
नासा ने अभी सर जेम्स वेब टेलीस्कोप
भेजा है अराउंड 15 लाख किलोमीटर दूरी पे। हाँ जी बोलिए।
स्पेस में सर, हमको सर जो भी फ्यूजन हो रहा है स्पेस में,
जो भी
फ्यूजन हो रहा है, फ्यूजन रिएक्शन
फ्यूजन रिएक्शंस हो रहा है,
वो इलेक्ट्रोमैग्नेटिक वेव्स रिलीज करती हैं।
हाँ जी
इसलिए हम सर टेलीस्कोप सर
देखते हैं,
डिप्लॉय कर रहे हैं।
बिल्कुल बिल्कुल।
और बहुत सी ऐसी वेव्स हैं जो अर्थ तक नहीं आ पाती, इसलिए हमने स्पेस में जेम्स वेब टेलीस्कोप भेजा। तो सर मैंने कुछ किया था सर, जो डिफरेंट एलिमेंट्स होते हैं वो डिफरेंट तरह के इलेक्ट्रोमैग्नेटिक
बिल्कुल, क्योंकि सबका वेव अलग है, क्योंकि सबका रेडिएशन अलग निकलेगा, उनका एलिमेंट्री उनका इलेक्ट्रॉन पोजीशंस अलग अलग है। तो जब वो इलेक्ट्रॉन जंप करते हैं अपने साइक उसमें, तो वो अलग अलग टाइप का रेडिएशन पूरा सेट वो होगा। यही क्वेश्चन है
इससे हमें ये पता लग सकता है
कि कौन कौन सा एलिमेंट कहाँ है। Sir is answering when we are asking, sir. हाँ 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 हाँ. Okay, okay. So I'll try to repeat the questions. Thank you, ma'am. Thank you. Okay. You know, I have observed a very, and I didn't think of it when I was a student, but I have observed a very, I should say, exceptional characteristic of students. That is, that till they are sitting quietly, they get tired. You let them loose for 5 minutes. They will talk and talk and talk, and they will refresh. मैं आज तक समझ नहीं पाया है क्यों होता है। चुप बैठ के आप थक जाते हो। सर पिछला 1.5 घंटा से चुप बैठे हैं, 5 मिनट बात कर लेना, है ना, बहुत इंपॉर्टेंट है सर। ठीक है, बस 5 मिनट छोड़ा, फुल ब्रॉडकास्ट, है ना, फुल ब्रॉडकास्ट मोड में जाते हैं। 5 मिनट बाद एकदम चेहरा फ्रेश। यस सर, अब बोलो सर। ऐसा क्यों होता है? कैन समवन एक्सप्लेन दैट? हाँ, so human being is more of a psychological being, should we say, rather than a very rational, है ना, we are source of entertainment, हाँ, social animal। इसीलिए सर जब तक सोशलाइज नहीं करते तब तक हम थक जाते हैं। मतलब आप नेचर के पूरे रूल्स के बिल्कुल अगेंस्ट जाते हैं। हाँ जी, अच्छा, यू हैव एन आंसर टू दिस? मतलब सर जब तक आंसर नहीं दे दूंगी तब तक। वेरी गुड, बोलो बोलो, दैट शुड बी द स्पिरिट। यस, ये आप मेरे क्वेश्चन का आंसर दे रहे एटम से। सबसे पहले मुझे आपको नमस्कार करना चाहिए। मतलब आपने मेरा पढ़ाया इतने अच्छे से समझ लिया है कि उसका आपने एग्जाम्पल बना के मुझे को समझाना शुरू हो गया। वेरी गुड, बोलो। हाँ हाँ, बिल्कुल ठीक है। मैं आई ऑल्सो नो दिस आंसर बिकॉज आई हैव थॉट, आई राइट। हाँ, सो बोलो, बिकॉज दिस इज व्हाट आई वांट यू टू स्पीक नाउ। यू नो, यू आर एग्जैक्टली डूइंग व्हाट आई वांट यू टू डू। बोलो। एनर्जी is very good, very good, very good. That's exactly the answer that I needed, because you are not focusing your energy. ठीक है, this is the problem. This is not the problem. This is your problem for most of you. You know, that's exactly why मैं बिल्कुल यही चाहता था कि आप बोलो, क्योंकि ये पहली बार मैंने क्वेश्चन नहीं पूछा है और हर बार आप जैसा इंटेलिजेंट बच्चा क्लास में होता है। ठीक है, बिकॉज यू आर नॉट फोकस्ड, यू आर नॉट एंजॉइंग द थिंग दैट यू आर डूइंग, दैट्स व्हाई यू वांट टू डू समथिंग एल्स। ठीक है, इफ यू स्टार्ट एंजॉइंग व्हाट यू आर डूइंग, मैं यहां से जाऊंगा भी ना तो पीछे भाग के आओगे। ठीक, और जैसा ही ब्रेक मिलेगा कॉपी खोल के वापस देखोगे कि क्या पढ़ा। ठीक है, आई जनरली सी आई डोंट नीड अ ब्रेक डिस्पाइट ऑफ द फैक्ट दैट आई एम स्पीकिंग। and I have to speak, probably many times I speak after one class and the second class and third class. But why I don't is because till now I have not reached a stage where I stopped enjoying my classes. The day that would happen, I will end doing this because I have already made enough money for lifetime. Okay, but I'm coming to the class because I enjoy doing this. And that's why I don't look into the watch to give a break. मुझे ज़रूरत नहीं पड़ती. क्यों? क्योंकि मैं आपसे बात करना एंजॉय करता हूँ, आपको समझाना एंजॉय करता हूँ. आप भी उस समझने को उतना ही एंजॉय करने लगो, फिर आपको कभी ब्रेक की जरूरत नहीं पड़ेगी. ठीक है? और वो इसलिए भी जरूरी है बिकॉज इफ यू वांट टू राइट अ 3 hour पेपर ट्वाइस अ डे फॉर 2-3 days in continuity, which means double classes 4-5 days, and focus and concentrate and bring out the best that you have to practice. Means में यही करना है. Those 3 hours you have to recall everything that you have ever read and present in the most beautiful manner that you can. That will ensure that you get the rank that you want. मैंने आपको पहले दिन बोला था, this is second only. You have the potential, but I'm sorry, most of you will never make it. And that difference is focus. ठीक है? अच्छे से याद रखो, ये जो भी आपके आसपास बैठे हैं, 10 महीने बाद इनमें से किसी की शक्ल नहीं दिखेगी. 80%. 2 साल बाद 90%, 5 साल बाद 99%. So they don't matter. And if they don't matter and you are still talking, right, when you are giving the best of your life, खुद सोचो कि how logical an investment of your time you are doing. ठीक है? वो सोशल एनिमल ना कुछ दिन तक ही रहता है, राइट? वो सब सोसाइटी छोड़ के भाग जाएगी, सिर्फ क्लास खत्म होने दो, राइट? अगर अंदर फायर है तभी कुछ होगा. अगर फायर ही बुझी हुई है तो एक्सप्लोड कर जाओगे. अभी सिखाया. ठीक है? तो अपना डायनामिक इक्विलिब्रियम बनाओ. नेचर टीचेस यू लॉट ऑफ लेसन्स, राइट? यू जस्ट हैव टू लर्न. ओके? फायर है पक्का? देखते हैं. ठीक है? ओके. सर एकाएक इतना सीरियस मत कर दिया करो. अच्छा बात बोलो, क्लास खत्म करो, भेजो. ओके? आई फील कि यार जब मैं आप लोग के साथ इतना एंजॉय कर रहा हूं तो हाउ कैन आई चीट यू बाई नॉट टेलिंग यू व्हाट आई नो अबाउट यू. ठीक है? देन आई विल बी चीटिंग विद यू ना, राइट? तो फिर ग्रेजुअली मेरे अंदर वो गिल्ट बिल्ड होने लगेगा. और जब वो गिल्ट ज्यादा हो जाएगा तो फिर आई विल स्टॉप डूइंग दिस. बिकॉज देन आई लुक एट माई अकाउंट, आई विल से गुड इनफ. हो गया? क्योंकि आपके साथ तो मैं गिल्ट बिल्ड कर रहा हूं, तो आपके साथ में गिल्ट बिल्ड नहीं कर सकता हूं, है ना? और गिल्ट कब होता है? व्हेन यू कैन डू समथिंग एंड यू आर नॉट डूइंग. ये सोशल एनिमल है, राइट? हमने सोसाइटी को उल्टा समझ रखा है. वी थिंक सोसाइटी इज अबाउट मेकिंग नॉइज. इट्स नॉट अबाउट मेकिंग नॉइज. ठीक है? वैसा तो चिड़िया भी करती रहती है, बट जानवर भी आवाज तभी करता है जब जरूरी हो. तो आप तो बेस्ट जानवर हो. Come back. So I hope there are no other questions, right? जितना आप लोग के मन में वो सब था वो सब आपने निकाल लिया during the break and before the break. So now we should start. Okay. So now that we have understood this much, the stellar nebula part along with the planets, okay, these small objects, right? So once you have those small objects, they will gradually turn into planets and they will keep rotating. Thanks to that, what we understood is the first star will be born in the generation. Once that dies, it has made enough for its coming generations. Okay? And that enough that it has made is basically what will give the planets. That's the fusion reaction. Thanks to fusion, it has made all the elements. Thanks to all those elements and hydrogen, next generation you will again get a star, and around the star, you will also have planets. So this is exactly how the star and planet system is formed. Is this clear? पक्का? मतलब मैटर तो समझ गया ना, मतलब यस बोलने में एनर्जी स्पेंड कर सकते हैं, ऐसा नहीं कि हाँ आंख से ही बोल दिया, उतना दूर मेरा इतना अच्छा आंख नहीं है यार. यस, एवरीवन अंडरस्टैंड्स दिस मच? पक्का? लास्ट बेंच पीपल, यू आर आल्सो, एवरीवन इज क्लियर ना? ठीक है. इफ आई एम नॉट आस्किंग यू डायरेक्टली नहीं पहुंच पाता हूँ, आई एम नॉट एबल टू सी, डजंट मीन दैट आप लोग कोई सेकंड ग्रेड सिटीजन्स ऑफ द क्लास हो. ठीक है. द मोस्ट इंटेलिजेंट ऑलवेज सिट इन द लास्ट बेंच. पहली बार क्लियर आंसर आया है. यस सर, बिल्कुल सही बोला आपने. ओके, so I hope everyone is clear on this, right? So now you have a star and a planet system, right? That's exactly how the solar system was also formed. Clear? ठीक है. So from the stellar nebula, you have the star, new star, I should write new star plus planets and other celestial bodies are formed. When we say other celestial, that means star and planets are also celestial bodies only. Any object in the universe is called as a celestial body. That's a common name for any object in the universe, right? Celestial body. Okay, so your sun, your stars, all of them are celestial bodies. Clear? So you have new star plus planet plus other celestial bodies formed. Clear? Right? And that's exactly how the sun and the solar system with the earth as a planet was formed. Clear? Pakka? Any doubt? None? Okay. Now, how and when was and what do you call these other celestial bodies? The other celestial bodies is something that we will again talk in the last class. Right? ये हम last में बात करेंगे, अभी नहीं करेंगे. ठीक है? Because I have to bring you to the earth first. Other celestial bodies will be things like asteroids, comets, lot many other things which you have in the solar system also. Okay, but we'll talk of dwarf planets, etc. We'll talk of all that in the last class. Okay. The fan. Ma'am, can we ask the technical, the staff to put the fans on? Just the fans, not the AC. Ask them not to put the compressor on, otherwise it will become cold. Okay. So, when you talk of the new star and the planets, basically all planets of the universe, all planets of the universe, except those of solar system are called as, क्या बोलते हैं? Very good. Are called as exoplanets. So all the planets of any other star in the universe, we call all those planets as exoplanets. Okay? And the planets of the sun, we call them as planets. So the word planet is used only for the exoplanets of the sun, right? Only for sun we use the word planet. For all other stars, If they have a planet, we call them as exoplanet. That's how we differentiate our solar system from other star systems. Is this okay? Clear? ठीक है ना? So all these exoplanets, etc., again you will either do in your science or the last geography class. Now let me bring you to the solar system. Even our solar system was formed this way. Even our solar system was formed this way. Right? Exactly the same process had started, and thanks to that we got our solar system. I have to tell you that story. Okay, how our solar system came into existence. But just before that, there is one last thing that I want to touch here before I go beyond, which is we have talked of the singularity, we have talked of the Big Bang, we have talked of all those four things and the four forces. We have seen how galaxies and stars and all those different nebulas, heavier elements, etc. are formed and we have reached up to the Earth. Okay. Before I take you beyond, there is one more number that I want you to write somewhere. There is something called as universe and you have observable universe, right? What is the difference? We think that there is only a certain part of the universe which we have been able to see, right? Which we call as the observable universe, right? So the universe to us is the observable universe, because we also think that maybe there is a part of the universe which we are still to observe. Okay, so wherever you will read the good sources, they will generally use the word observable universe for universe. Okay, so observable universe means all the part of the universe that we have been able to see. Whereas the Big Bang started the observable as well as the unobserved universe. Okay, so our universe started with Big Bang. It has an observed part and it has a probably maybe an unobserved part also, which we are still to observe. Is that okay? What is the size of the universe? The observable universe that we know has a size because that far we have been able to see. The unobservable part of the universe we don't know. Okay, so what is the size of the observable universe? It is approximately 95. The number is around 93 point something. I'll round it off to nearly 95 billion light years. Okay, 95 billion light years is the size of the observable universe. I want you to note this somewhere. Okay, what is the size of the observable universe? Approximately 95. You can put the number somewhere around 93, but approximately 95 billion light years. Okay, 95 billion light years. Which means if you go on either side or any side from the Earth, or from the center of the universe, or from the Earth, because we are measuring from our position, on any side you can go up to nearly 47.5 billion light years distance. Now you might ask me a question. That's exactly why I told you the expansion of the universe. It's sir, in 13.7 light years, billion light years, how has the universe expanded to 43 billion light years? Right? Or how? You know this. That's exactly because of the expansion of the space. Right? Because, because light year is time. When you say year, that is, the distance that is traveled. So when you are putting that number, it's basically distance. It is not time. How much time it has taken? 13.7 billion years. How much distance it has expanded to? 14.3 billion light years. Is this understood? Right? That's how that is how much the universe has expanded. So in 13.7 billion year time, the universe has expanded to a distance of 47.5, approximately 47.5 billion light year distance. Is that okay? Are we under? It is something like in 5 minutes, how much something has become bigger. So you can say in 5 minutes it has become bigger by 2 kilometers. right? So in 13.7 billion light years, how much has the universe expanded? Approximately 47.5 billion light years in all directions. That is the expansion of the universe. Is that okay? Expansion is distance. And when you say billion light years, that is, sorry, when you say billion years, that is time. Okay, so billion years और billion light years में difference है. Billion years is time, billion light years is distance. ठीक है, जैसा मैंने अभी बोला ना, जैसा हम बोल सकते हैं कि 2 मिनट में 2 किलोमीटर एक्सपैंड हो गया. ठीक है, तो हम नॉर्मली कंफ्यूज इसलिए होते हैं क्योंकि हम दोनों के अंदर ईयर वर्ड यूज कर रहे हैं, राइट? बट बोथ ऑफ देम आर डिफरेंट यूनिट्स. वन इज फॉर टाइम, द अदर इज फॉर डिस्टेंस. Okay, so in 13.7 billion years we have expanded to a distance of approximately 47.5 billion light years. अब बोलो. हाँ जी. It is actually at the outer edges it is, and that's exactly why we talk of observable universe, because even theoretically we think that we might never be able to see the unobservable part because that is expanding faster than the speed of light. ठीक है, so if something is going faster than your bullet, you can never catch it. आपने किसी को गोली मारा और वो है ना, वो गोली का स्पीड से भी तेज भाग रहा है, तो गोली तो उसको लगेगा ही नहीं कभी. सिंपल. ठीक है, right? And our only source of knowing about the universe right now is electromagnetic radiation. That's exactly why we are doing all those experiments around gravitational waves, because that is another source of knowing the universe. Till now we know about the universe only from light and its equivalents, gamma radiation, X-ray radiation, radio waves, etc., and all of them have a fixed speed. Okay, so if we have to know about the universe where the speed is not able to tell, the speed of light, we have to figure out other modes of knowing, right? That's exactly why we are doing all those experiments, to figure out other modes of knowing the universe, such as gravitational wave. Okay, that's why we are trying to understand gravitational waves better, because they would travel at a different rate. They are not light waves. Okay, and they would have different effects. Clear? Of? I exactly don't know, but they will tell you something else, something that the electromagnetic radiations are not able to tell. Okay, that's a different character. The way you do different, you have a magnetic resonance test for human body, right? And then you have other tests also, X-ray. So X-ray tells you something, magnetic radiation tells you something else. Same way is about the universe also, right? Till now we are knowing about the universe only from electromagnetic radiations coming from other sources. Once we have a different source altogether, that can tell you something else. Okay, it's not only the wave, it is also the characteristics. Okay, so we might figure out. Okay, that's it. So having talked of the size of the universe, I'll just come to you in a moment. Having talked of the size, now we have to talk about the formation of the sun and the earth, and then we'll go into the earth. Is that okay? That is the sequence. Give me a moment. Is that okay? No other doubt? Yes. कौन था? Do you need to remember the data, the size of the universe? They can ask you a question. That's why I'm giving you. In prelims. Universe related question, they do ask you in the science section of paper 3 at times. But in prelims they can ask you, because they have gradually started getting into those domains. Okay, they have started going into space. Not for mains. But because for prelims it is important, so I'm giving you. Okay. So now come to formation of solar system. So in this, I'll start, first I'll leave a space. Okay, then I'll come to sun. Okay, the sun. So when did the sun started forming? Started forming around 5.6 billion years before present, and was formed by 4.6 billion years before present. It was already formed along with planets. including Earth. Along with planets including Earth. This is the story. So when did the sun and the planet started forming? Around 5.6 billion years before present. They started taking shape from the stellar nebula. Okay? And by 4.6 billion years before present, 1 billion year later, the Earth and the sun were already formed. So they started and they were formed. Is that okay? Fully? Right? Now, what happened before that? You need a supernova explosion. Supernova explosion, which formed the Earth and the sun, it took place approximately 8.5 billion years before present. The supernova explosion, which formed our sun's nebula, took place approximately 8.5 billion years before present. Not given in your NCERT, but please do note. Okay? So that supernova explosion took place around that. Okay? And that led to the stellar nebula which formed the sun. Okay? So supernova, and then what will I get? I will get the stellar nebula which formed sun. So approximately 8.5 till 5.6 billion years. We had that stellar nebula phase in which all the elements were there. Okay? Because in that supernova, all those elements would have been formed, which formed our Earth and Jupiter and whatever. Okay? And they remained in the nebula form for approximately 3 billion years. 5.6 billion years before present, sun started taking shape. 4.6 billion years before present, sun and the Earth and everything was already formed. Do we get it? And all the elements, etc. So all the story is clear to everyone. This much, I believe, nothing too complicated. Right? That's why I took so much time to bring you up to this stage. Hopefully written also. Okay. Then, so now we have the Earth. Welcome to Earth. बहुत देर से स्पेस में घूम रहे थे. Okay, so let us talk about the Earth story. So Earth was already formed approximately 4.6 billion years before present, but was it the Earth on which we live? Not exactly. Okay, so now we'll start the Earth story. Should we? ठीक है, यहां से आपका ज्योग्राफी स्टार्ट हो गया है. अभी तक आप एस्ट्रोनॉमी में थे. Is that okay? Right, so till you are talking of the solar system, universe, etc., you are talking of astronomy. Right? Universe का geography था वो, where everything was formed and the forces were decided. Right? Now you are on Earth. So once you are on Earth, your physical geography, you know, the way you talk of land, water, atmosphere, all this will start. And the ecology environment will also start and human geography will also start. So this is where we'll talk of all that. Okay? So once you talk of the Earth, should we start? Ready? Right? Right? Good. So, if you have written this much, now write this line. The Earth formed around 4.6 billion years light year before present. Earth formed around 4.6 billion light years. So I'm so sorry, ये light year मुझे छोड़ नहीं रहा है. 4.6 billion years before present. 4.6 billion years before present was a barren planet. Barren, B-A-R-R-E-N, barren, uninhabitable. Barren, uninhabitable. Barren means something which is desert-like. Nothing grows, nothing was there. Okay, barren, uninhabitable planet having an envelope of lighter gases, lighter remaining gases, envelope of lighter remaining gases around itself, lighter remaining gases around itself, within bracket hydrogen and helium. What gases were there? Hydrogen and helium. Known as the Earth's first atmosphere. Known as the Earth's first atmosphere. Gustav? This atmosphere being made up of very light gases, this atmosphere, the first atmosphere being made up of very light gases was lost to space. Being made up of very light gases was lost to space. One, due to Earth's gravity not being able to hold it. Earth's gravity not being able to hold it. And second, solar winds, within brackets solar charged particles. What are solar winds? They are solar charged particles. Solar charged particles, bracket close, were strong enough. Solar winds, within brackets solar charged particles, bracket close, were strong enough to blow away the Earth's first atmosphere. To blow away the Earth's first atmosphere. Okay. So this is how our first atmosphere, which we had, which was the remnant of gases which were there since Earth's formation, they were carried away. Okay, so we had an atmosphere but we lost it. Clear? Right? Then this initial Earth, which is also known in some sources as Gaia, spelling on board. This initial Earth, which is also known in some sources as Gaia, had a large collision with a nearby Mars-like planet. Had a large collision with a nearby Gaia, had a large collision with a nearby Mars-like planet, which is called as Theia, Theia, spelling on the board. So we call it as the Gaia plus Theia collision, right? Mentioned as, I think the word in your NCERT is big splat for it, right? The big splat, also called as giant impact, right? Called as big splat or the giant impact. This is what the NCERT gives you, the name of these words. It doesn't give you the name of the colliding planets, but it gives you the name of the process, right? The process was called as big splat or giant impact, which took place around 4.44 billion years before present. Gaia plus Theia, we had a giant collision of these two that giant collision is called as big splat or giant impact. Okay. And when did it take place? This process took place 4.44 billion years before present. Is this okay? Right? This led to the formation of this giant impact. This giant impact led to the formation of present Earth plus Moon, Earth's only natural satellite. Present Earth plus Moon. What is Moon? Moon is Earth's only natural satellite. Okay. So this is how our present Earth and the Moon were formed. Okay. Before 4.44 we didn't have a Moon, we didn't have the Earth also the way we had, and we had a nearby planet also. Those two collided, they gave us the present Earth and the present Moon. Is this okay? Clear? Now, let us talk of, so this is exactly when we come to our Earth. Before that we had come to previous Earth, okay, which no more exists because the collision modified it. So this is the present Earth, right? But was the present Earth exactly the same ways that we are on? For example, if I ask you on the present Earth that we are on, what all do we have? What all major things that we have on the Earth? We have an atmosphere, we have a ocean body, right? And we have land also. I think in last class I did show you the amount of water that we have on Earth. वो डॉट दिखाया था. आपको ऐसा एक डायग्राम नहीं दिखाया था? अच्छा, मे भी रह गया होगा, कोई बात नहीं, कोई बात नहीं. When you talk of the ocean on the Earth, okay, we know that how much ocean do we have on Earth? Is that the ocean on the Earth, or it is the layer, the surface of the Earth covered with ocean? It is the ocean. Do we have that much water up to the center of the Earth? That is the surface of water covering the Earth. So 70% of Earth's surface is covered by ocean water. First you have to understand the Earth. Suppose this is the land, okay, land body. So from the center of the Earth to the land, what is the distance? Approximately 6400 kilometers. From the center to the land, that is the distance. And when you go in the atmosphere, हमने ये सब बात किया था शायद, ये तो किया था ना, that when you talk of the atmosphere, what is the height? 3500 kilometers. Okay, and on this land surface that you have a layer of water, and how much of the Earth's surface, land surface, is covered by water, oceans? 70%. So only this is covered. 70% of the land is covered by ocean layer. And what is the thickness of the ocean layer? लिखा है हमने वो भी, approximately 4.5 kilometers. So if you want to see how much water, total water that we have on the Earth, the total water on the Earth is that water, that one drop. That one big drop that you see, that is all the water that we have on the Earth. If that is the shape of the Earth, giving you in perspective so that you can compare. So if that is the shape of the Earth, all the water on the Earth is that big drop. That big drop is spread as a layer. That layer you call as the ocean, plus the water in the river and the lakes and whatever. So all the water on the, so the Earth is a watery planet, but it is not watery to the extent that we think. 70% ocean है तो अंदर भी पानी भरा है, नहीं, सारा पानी उतना ही है, that one big drop. Okay, I think इसी डायग्राम का नीचे बना होगा, ये देखो, all water on, in and above Earth. So when you add up all that water, that is one big drop. Then when you talk of the liquid fresh water, that is a smaller drop. I think वो इसमें दिया हुआ है diagram में, और छोटा सा drop दिख रहा है. That is the fresh water drop. All the fresh water that we have. Okay, and fresh water lakes and rivers, और छोटा drop. इस डायग्राम में शायद है वो है. That's all. Okay, ठीक है. तो हम बोलते रहते हैं ना, बहुत सारा पानी है, वही हमारा बहुत सारा पानी. ठीक है. और ocean water is of no use to you directly as of now because of the limits in technology that we have. Anyways, so when you talk of this present earth, we have the water. I hope now you understand how much water we have. That is all the water that we have. And then above that you have the atmosphere. So you have the oceans. The present earth has an ocean, or it has oceans, it has atmosphere, it has land, है ना, इतना कुछ है. And then it has life. That is present earth. But was all this there 4.44 billion years before present? The answer is no. None of them was there. The earth 4.44 billion years before present was a very different earth. Okay, it was a hot molten lava covered earth. The whole earth was covered by hot molten lava. That's it. वही था. And where did the lava come from? That collision. That huge collision that we had melted almost all the surface of the earth. Right? It was so big an impact that it almost melted the surface, and inside the earth we still have lava. So even at that time we had lava. So the lava from inside started flowing to the surface because the surface was all molten. Can you imagine? कर सकते हैं ना, बहुत मुश्किल नहीं है imagine करना. It is like a chocolate ball in which the center is filled with liquid chocolate and outside you have a hard cover of chocolate and you put it in the oven and put the oven on. What will happen? Gradually the outer chocolate layer will melt and what will start flowing to the surface? The liquid chocolate. Exactly like that. So the earth 4.44 billion years before present was a hot molten surface planet. Right? Was there atmosphere? No. Was there oceans? No. Was there land? No. Life? Good, we were not there. ठीक है, नहीं तो सब के सब KFC के जैसा फ्राई हो गए होते. Right? So hopefully we understand this. Right? So now from that earth we have to come to the present earth. So present earth, let us start the story. 4.44 billion years before present. We start the story from there and then we continue. ठीक है? I will dictate all the things that I said. You will note down. Should we? Right. So write down that presently on our earth, we have a layer of habitable atmosphere. We have a layer of habitable atmosphere within bracket rich in, what is this atmosphere rich in? Rich in nitrogen and oxygen. 78 and 21, 99%. Rich in nitrogen and oxygen. If you want you can write the percentage also. 78 nitrogen, 21 oxygen. And what makes it habitable for us? Oxygen. What makes it habitable for plants and all? Oxygen and nitrogen. ठीक है, and CO2 also. उनको CO2 भी चाहिए. But we are rich in this because of which we are able to live. Otherwise, if this was not there, O2 was not there, if you go outside, choke. Is this okay? Then first habitable atmosphere, comma or semicolon, right? Close that bracket, then put a semicolon. Ocean, oceans, right? You have many oceans. So oceans or continuous ocean surface, whichever way you understand. We have a continuous ocean surface. ठीक है? Oceans or continuous ocean surface. Third, again a semicolon, then land land both above water, land, comma, both above water as islands and continents, land, comma, both above water as islands and continents, and below water, below ocean water as sea floor or oceanic crust. Sea floor, also known as oceanic crust. As sea floor, also known as oceanic crust. ठीक है? So this is the land that we have, and semicolon, and lastly life. Life, the biodiversity. Life, semicolon. What is the fourth thing that you have on the earth? Life or the biodiversity that we have. Life or the biodiversity that we have. Okay, very good. Next paragraph. But 4.44 billion years before present, 4.44 billion years before present, we had none. We had none, and the earth was not the way it is now. We had none, and the earth was not the way it is now. Full stop. At that time, due to the giant impact collision, the Earth's rocky rigid surface was all molten into lava, into hot lava, all molten into hot lava, and hence Earth was like a ball of hot lava, and hence Earth was like a ball of hot lava with no atmosphere. Earth was like a ball of hot lava with no atmosphere. Why? Because the atmosphere was already lost earlier. The first atmosphere of the earth was already lost. ठीक है? Good enough? ठीक है? Good. So now let us go beyond this. So gradually from the hot molten lava ball that we were, we have to see how we reach the present stage. Now when you say hot lava ball, I hope have most of you seen hot lava somewhere in TVs, obviously. Real life में तो हाँ देखा है टीवी पे hot lava है ना. I'm not talking of hot lava chocolate cake, वो भी देखा होगा मेन्यू में, but मैं hot lava पूछ रहा हूँ. Volcanic lava, have you seen? What does it look like? Red, hot, liquid flowing on the surface, right? So just imagine the whole earth was like that. And where do you get to see lava? You see them at volcanoes. Okay. So just imagine what would have been the state of earth at that time. Right now you see lava where you have volcanoes. At that time everywhere was lava only. So how many volcanoes? Can you imagine? Because more lava was coming from inside also. It was all hot, molten, moving. So you can imagine how many volcanoes would have been taking place at that time. So basically the whole earth was covered with numerous volcanoes. Why? Because the earth was very hot at that time. Even presently the earth is hot, but it is not so hot, it has cooled down. So you still have some lavas and volcanoes. Few places volcanoes keep happening, but at that time the whole earth was full of volcanoes only. There was no land. Okay. Now my question to you is, what all comes out of the lava? Because whatever comes out of the lava now must be coming out of lava at that time also. The earth's interior was the same. It is only that over the period of time the earth has cooled down. Okay. But what do you think comes out of lava? Or when a volcano takes place, what all comes out? Huh? from hot erupting volcanoes, what all comes out? Gases such as, what gases comes out? You have different gases such as ammonia, not nitrogen, right? Ammonia और nitrogen में अंतर है. So ammonia. And how do you know? Because you can go to any volcano which is taking place and you can inspect the gases and test the gases and figure out what gases are coming out from them. Whatever gases are coming out from them right now must be coming out at that time also, right? So we find that we get ammonia, we get methane, and this is an answer that not you are giving, this is an answer which the volcanoes themselves are giving, because from volcanoes still these gases come out. So you have ammonia, methane, carbon dioxide, so on. But you neither had N2 nor had O2, because from volcanoes O2 and N2 do not come out still. Okay, so O2 and N2 are not coming out, and because they don't come out now, so that time also they won't have come out, because inside the earth there is no oxygen factory. Oxygen is there, but that is in the form of oxides, carbon dioxide, other oxides, but not in the form of pure O2. Is that okay? So these gases were coming out, and steam, which is H2O gas, right? Because steam comes out of volcanoes still, right? When you go to any volcanic site, steam still comes out. Because steam is still coming out, that means steam must be coming out at that time also. Simple. Okay. And what do we mean by steam here? Steam means H2O in the gaseous form, the hot gaseous form. Is this clear? So these gases were coming out, and these are relatively heavier gases. Okay, so the gravity of the earth was able to hold them. Because the gravity of the earth was able to hold them, what will they form? They will again form a layer around the earth. They will cover the whole earth with a layer of these gases. So once your earth is covered with a layer of these gases, what can you call? You can say atmosphere. है ना? Cloud patch होता है. जब everything is covered, then it becomes a atmosphere, है ना? Cloud is a patch in the atmosphere. जब हमने पहले बोला universe में hanging patch is called as cloud. The whole universe you don't call as cloud, है ना? ऐसा तो नहीं ऊपर जाकर के एकदम मतलब सब कुछ नहीं दिख रहा तो ये बोलते देखो एटमॉस्फेयर को देख के बोले कितना अच्छा क्लाउड है. लोग बोलेंगे तबीयत खराब हो गया इसका. किधर है क्लाउड? ये एटमॉस्फेयर है. ठीक है, तो दोनों का अंतर पता है ना? पक्का? ठीक है. सो यू हैव द एटमॉस्फेयर एंड दिस इज द सेकेंड एटमॉस्फेयर. सेकेंड atmosphere of the earth. So this is how around 4.44 billion years and later the second atmosphere of the earth was formed. The first was lost, the second was formed. And what is this atmosphere rich in? Not hydrogen and helium, but ammonia, methane, CO2, etc. Sulfur dioxide, carbon monoxide, those are the gases which come out from volcanoes. Burn type of gases. So those gases were coming out, and hence this was a very intoxicating atmosphere. It was not the atmosphere in which you live. It was the atmosphere that Delhi is building nowadays. That too partly. थोड़ा ही बनाया हमने ऐसा, अभी बिल्कुल वैसा नहीं बनाया. ठीक है? So I hope you understand. So this was a very non-inhabitable type of atmosphere, poisonous atmosphere. Clear? So this was the second atmosphere of the earth, and it was formed around 4.44 billion years before present over few hundred million years. Your books say that before 4 billion years before present, the second atmosphere was already made. Before 4 billion years before present, the second atmosphere of the earth was already made. Is this clear? We already had ample gases released so as to give us almost a atmosphere around the earth. Okay? Good. And that's exactly where I leave you. ठीक है, क्योंकि हर रोज मैं आपको जबरदस्ती एक्सटेंड नहीं करूंगा. आई डोंट लाइक एक्सटेंडिंग क्लासेस, आई डोंट लाइक टेकिंग इट टू लेट. राइट, वी शुड हैव सम रिस्पेक्ट फॉर टाइम. राइट, सो I would expect you to be in the class on time and I will leave you on time. Okay? So, should we? Is this much understood? Next class we will start with what happened to the steam, because the gases that has given us the atmosphere. Where will the clouds come from? The steam will give you the clouds. Okay? So, we will start the story from there. Now, where do you read from all this? You read from the second chapter of NCERT, Fundamental of Physical Geography, chapter number 2. I'm doing that chapter for you right now. Okay, and we are going along with that chapter. You have to go in the same sequence and do that chapter. So please read it and come. Tomorrow we have a class. So let us meet tomorrow. That's it. Thank you. Ma'am, is there any doubt that you want me to take up? None? Online people also, I don't see any doubt. That's it. Thank you.